Nun, was sind die bisherigen Ergebnisse? Was hat der Sojourner gebracht? Nun, das erste, wichtigste Ergebnis ist, es gibt kein Grün wie auf der Erde. Wir haben auch keine Marsmännchen gesehen. Mit anderen Worten, es gibt im Augenblick kein Anzeichen von Leben auf dem Mars. Die Steine, die Untersuchung der Steine haben ergeben, dass sie basaltartig, also lavaartig sind. Das bedeutet, dass sie sehr ähnlich sind wie die auf der Erde. Und das bedeutet wiederum, dass es früher Vulkanismus auf dem Mars gegeben hat. Vor langer, langer Zeit, aber immerhin. Außerdem hat man Reste, Spuren von Wasser gefunden, was zu erwarten war, denn man weiß, dass es auf dem Nordpol Eis gibt und dass es auch eine leichte Reichsschicht auf dem Boden überall gibt. Und das gibt es natürlich auf der Erde auch. Die Atmosphäre wurde gemessen zu 0,06 bar, also ein sehr geringer Druck im Vergleich zur Erde. Und die Temperaturen liegen im Bereich zwischen minus 20 und minus 80 Grad. Eine Frage, die mir sehr oft gestellt wurde, ist, würden Sie denn auch mal fliegen, Herr Walter, zum Mars? Ich habe das gerade schon angesprochen und die Antwort lautet, ja, ich würde fliegen, allerdings nicht jetzt. Ich würde erst fliegen, wenn ich relativ alt wäre, denn es gibt große Gefahren bei so einem Flug. Wir haben gerade die Strahlenbelastung angesprochen, es gibt aber auch manch andere Gefahren und davon erzählt Ihnen der nächste Beitrag.
Einmal Mars und zurück. Die Vision rückt näher. Im Jahre 2003 ist die internationale Raumstation fertig. Hoch über der Erde soll die Raumfähre für den Mars zusammengebaut werden. Hier müssen die Astronauten auf ihrem Weg zum Mars umsteigen. Der Zeitplan.
Start von der Erde 2018, Landung auf dem Mars Mitte 2019.
Doch zuvor müssen noch einige Probleme gelöst werden. Wie können die Astronauten vor der kosmischen Strahlung geschützt werden? Wie sollen sie die unendlich lange Zeit der Schwerelosigkeit heil überstehen? Wie kann die Kommunikation zwischen der Bodenkontrollstelle und dem Raumschiff sinnvoll gestaltet werden? Trotz Lichtgeschwindigkeit dauert es bis zu 20 Minuten, bis die Signale im Raumschiff ankommen. So werden die Astronauten zum Beispiel beim Landeanflug ganz auf sich und die Computerunterstützung angewiesen sein. Sie müssen völlig autark handeln können. Technische Probleme, die lösbar sind. Doch zu welchem Preis? Für 35 Milliarden Dollar sollen 3 Reisen zu haben sein. Die NASA zieht bereits alle psychologischen Register, um den Steuerzahlern die Marslandung schmackhaft zu machen. Angepeilt ist dafür der 20. Juli 2019, genau 50 Jahre nach der ersten Mondlandung. Damit enden auch schon die Parallelen. Verabschiedeten sich die Astronauten vom Mond schon bald wieder Richtung Erde, so soll bereits mit der ersten Marslandung der Grundstein zur Besiedlung gelegt werden. Bunker zum Schutz vor gefährlicher Strahlung nach Sonneneruptionen, Fabriken zur Ausbeutung der Bodenschätze, das sind die ersten Wahrzeichen der Marskolonie. Denn Versorgungsflüge können nicht beliebig oft stattfinden. Lediglich alle 2 Jahre öffnet sich für kurze Zeit ein günstiges Startfenster. Die Marsbewohner sind völlig allein auf sich gestellt. In den kühnsten Träumen der NASA-Visionäre wird aus dem roten ein grüner Planet. Terraforming. Durch eine langsame Erwärmung ändert sich das Klima, Eis schmilzt, Wasser wird verfügbar. Nach Tausenden von Jahren gibt es einen künstlichen Treibhauseffekt.
Ja, ich denke, jetzt ist wieder Zeit für Zuschauerfragen. Ich habe hier eine Menge Anfragen vorliegen und ich gehe gleich rein. Herr Faber, sehe ich hier. Herr Faber, einen schönen guten Abend. Sie sind live hier in Glasklar.
Ja, ich habe eine Frage, und zwar die NASA setzt ja hauptsächlich auf Flüssigkeitsraketen. Gibt es auch andere Entwicklungen, zum Beispiel Photonen oder magnetische Antriebe, die erforscht werden und die vielleicht sogar für diese Mars-Exkursionen dann vielleicht besser sind, weil sie schneller sind?
Ja, es gibt diese neueren Antriebe. Der Nachteil dieser neueren Antriebe ist, die Leistung ist im Augenblick sehr, sehr gering. Das heißt, das Einzige, was einem übrig bleibt, sind die Flüssigkeitsantriebe und die Feststoffraketen, wie sie zurzeit beim Shuttle Anwendung finden. Ich glaube, außer diesen beiden Dingen hat man zurzeit keine Alternative, um es nochmal zu sagen. Photonentriebwerke, magnetische Antriebe, all die sind viel zu schwach, um einen großen Schub zu erzeugen.
Danke, ja? Ganz herzlich.
Gut, tschüss. Alles klar. Wir haben jetzt noch die Frau Dinter. Frau Dinter, einen schönen guten Abend.
Ja, guten Abend, Herr Walter.
Schönen guten Abend.
Ich habe die Frage, wie das mit der Datenübertragung von Pathfinder nach Pasadena ist.
Ja, das funktioniert so. Von der Erde aus, aber ich denke, da fragen wir ganz einfach mal Herrn Jaumann, der ja auch noch dabei ist, weil er leitet diese ganze Angelegenheit. Herr Jaumann, können Sie mich hören?
Ja, ich höre Sie.
Die Frage ist, wie funktioniert das eigentlich mit der Datenübertragung zum Mars von der Erde?
Von der Erde aus wird ein Kommando von relativ großen Antennen der NASA, dem sogenannten Deep Space Network, gesendet. Das geht natürlich nur, wenn die Erde vom Mars aus sichtbar ist. Und genauso geht es auch mit den Daten, die auf dem Mars gesammelt werden, wieder zurück zur Erde. Das Ganze ist natürlich nicht beliebig verfügbar, weil die NASA auch noch andere Missionen hat, wie zum Beispiel Galileo, sodass Pathfinder hier nur ein bestimmtes Zeitfenster bekommt. Das sind im Augenblick 4 Stunden am Tag. Ja. Und das ist eine Limitierung für die Datenmenge, die wir überhaupt zurückbringen können.
Das heißt also, das ist der Grund, warum wir nicht jeden Tag wirklich schöne Bilder sehen, ja?
Das ist genau der Grund. Wir können zwar an Bord sehr viel von diesen Bildern, die wir aufnehmen, speichern, aber der Flaschenhals ist das Zurücksenden zur Erde.
Frau Dinter, ich glaube, das war die Antwort auf Ihre Frage.
Ich bedanke mich, ja.
Einen schönen guten Abend noch. Ich sehe hier noch die Frau Galicker. Frau Galicker, ich kann Sie hören. Einen schönen guten Abend.
Guten Abend. Meine Frage ist ganz einfach. Wir haben schon so viel über Mars gehört, aber eine Frage habe ich noch nicht beantwortet bekommen. Wie hoch ist die Anziehungskraft des Planeten?
Nun, der Durchmesser des Mars ist etwa halb so groß wie der auf der Erde. Und das bedeutet gleichzeitig auch, dass die Anziehungskraft auf der Oberfläche des Marses ziemlich genau auch halb so groß ist wie auf der Erde. Mit anderen Worten, man würde fast doppelt so hoch springen wie auf der Erde.
Vielen Dank.
Gut, auf Wiederhören.
Wiederhören.
Ich sehe Herrn Rainer Hilmer. Herr Hilmer, einen schönen guten Abend. Sie sind hier live auf Glasklar.
Guten Abend, Herr Walter.
Ja.
Meine Frage ist, ich habe in verschiedener Literatur gelesen, dass es auf dem Mars Felsformationen gibt, die quasi das Gesicht, ein Gesicht darstellen, oder auch die Mars-Pyramiden.
Ja.
Was hat es damit auf sich?
Ich denke, es ist das Gleiche, wie Schiaparelli es vor 100 Jahren gesehen hat, Kanäle, und die gab es nicht. Ich glaube, das ist genau das Gleiche hier bei dem Gesicht. Wenn Sie das Gesicht mal gesehen haben, es sieht nicht ganz aus wie ein Gesicht. Es hat Schatten und Leuchtseiten und man erkennt fast daraus ein Gesicht. Es ist wie der Mann im Mond. Wenn Sie hochschauen, erkennen Sie auch manchmal einen Mann im Mond. Und wir wissen alle, dass da oben keinen Mann im Mond gibt. Und ist genau derselbe Fall hier auch.
Vielen Dank.
Es tut mir leid, aber so ist es. Auf Wiederhören. Und jetzt noch die letzte Frage. Ich sehe Herrn Feldner. Herr Feldner, einen schönen guten Abend.
Guten Abend.
Ja.
Ich hätte eine Frage im Rahmen von dieser Mars-Expedition. Hat man immer wieder auch gehört von einem Meteoriten, den man in der Antarktis gefunden hat, der vom Mars stammen soll.
Ja.
Jetzt kann ich mir nicht vorstellen, wie man da drauf kommt, dass dieser Meteorit vom Mars stammen soll überhaupt.
Genau die gleiche Frage hatte ich mir auch gestellt. Ich habe es auch nicht kapiert. Die Situation sieht folgendermaßen aus. Stellen Sie sich vor sehr langer Zeit, vor vielen Millionen Jahren, ist ein sehr starker Asteroid auf dem Mars gestürzt, hat dort Brocken herausgerissen und mit dieser hohen Geschwindigkeit sind die Brocken vom Mars weg, unter anderem dieser ALH 84001, so heißt dieser besondere Meteorit, den man auf der Erde gefunden hat. Er ist dann also weg vom Mars hin zur Erde und ist dort runtergekommen und man hat ihn dann in Grönland gefunden. Und aus der Zusammensetzung dieses Meteoriten kann man rückwärts schließen, er müsste eigentlich vom Mars kommen.
Okay, Dankeschön.
Gut. Ja, sollen wir noch eine Frage nehmen? Nein, wir schließen damit ab. Das war's. Jetzt kommt natürlich noch was ganz Wichtiges. Ich habe es am Anfang angekündigt. Die NASA ist ganz groß im Internet. Insgesamt hat sie 24 Millionen Hits pro Tag auf ihre Seiten, auf ihre Bilder. Das heißt, Internet ist im Augenblick sehr stark unterlastet. Internet ist in. Wir wollen es auch probieren. Sie werden mich sprechen können auf dem Internet. Sie sehen hier im Hintergrund gleich ein Bild, wo Sie sehen, wie ich mit Ihnen live chatten kann. Das heißt, in etwa einer halben Stunde werde ich mit Ihnen chatten. Bis dahin können Sie noch mit dem Telefon mit mir reden. Das heißt, wenn Sie noch Fragen haben, Sie haben es gerade gehört, rufen Sie doch ganz einfach an. Ich schaue mal zurück. Sie sehen hier jetzt im Hintergrund, das ist die Chatseite. Wenn Sie Ihre Fragen eingeben, ich werde mit Kollegen hier am Rechner sitzen. Ich werde Ihnen die Fragen beantworten, genauso wie Sie es gerade hier gesehen haben, per Telefon. So werden wir es machen. So, das war's für heute Abend. Ich hoffe, Sie haben Spaß gehabt. Ich hoffe, Sie werden noch mit mir Spaß haben, solange noch die Telefone laufen. Bis zum nächsten Mal. Vielleicht gibt es ja noch mehr Informationen vom Mars und dann sind wir wieder dabei. Einen schönen guten Abend.
People inside Pathfinder's mission control seem to talk funny.
We have that phantom packet thing on the TDS query where it turns up some odd packets.
34 meters, about a factor of 4 worse than the 70, so we can still get probably 1185 out of it.
Of course, whatever it is they're talking about isn't funny. It's serious science regarding the exploration of Mars. CNN was granted an exclusive look at a typical day, if there is such a thing, inside Pathfinder's mission control.
Put on the goggles and get the full stereo effect. it's quite obvious you're on a different planet.
Now we've got some really neat rocks in this area, Scooby-Doo and Casper. They want us to check those rocks out. And then from what I understand, there's a rock out in this vicinity called Wedge, which will be our next target. And then they actually want us to come back over in this area because there's some really neat tall rocks, but it looks to be very dangerous.
This is Pathfinder's rover control room, where computer commands are generated, telling the rover when and where to go.
As much as we explain it, this is the way we drive it, people still think that you're just joysticking it around and you've got live video to watch, which of course is impossible because of the time delay.
Want to play the name game? Those working on the mission have been naming the rocks they've seen in those glorious photos sent back to Earth. Cartoon characters are big. There's Yogi and Boo Boo, but no Beavis and Butthead. Another room contains a 3D reconstruction of the landing site.
Really, this model is just kind of an easy visual ways of getting a good view of the whole lay of the land as we do our planning activities and figure out where we're going.
The day starts with a group head session, and believe me, it's very heady.
So 158 turned it off and 35 proceeded to try and keep imaging.
Then they put information like that into a computer, and eventually it tells the spacecraft on Mars what to do next. It's no laughing matter. But hey, scientists are human too. Greg Lamont, CNN, the Jet Propulsion Laboratory, Pasadena, California.
Aren't you glad we don't deliver the news to you in that language? And that's all for this American edition. I'm Relita Vasilova. Stay tuned now for World Business Today. Pathfinder rover is being given some new freedom. NASA is letting the rover choose its own path to a designated target. This is the first self-guided trip for the six-wheeled vehicle. Until now, scientists on Earth have determined its route. The 3-meter excursion will test the rover's self-sufficiency.
NASA's little Mars rover Sojourner just keeps going and going, chugging back and forth between rocks with names like Scooby-Doo, Lamb, and Souffle. Greg Lamont reports on some of the highlights from this week's explorations.
For kids, a trip to Mars would be like going to a spectacular playground. For one thing, gravity there is only 1/3 of what it is here on Earth.
I think running around the surface would be a tremendous experience for a child because of the low gravity and the clearness of the surface. And I'm sure if you pounded your foot down into this dust, it would make a very satisfying cloud around your leg. And the kids would just enjoy that. Now, the parents wouldn't be so happy because the soil that we're talking about stains clothes like nothing else you'll ever find.
With more of a 12-color panoramic view of Mars in hand, scientists say the mission to Mars has been, well, extraordinary.
We have an extraordinarily healthy lander, an extraordinarily healthy rover, and extraordinarily healthy instruments, and I've already told you that the landing site was perfect.
Showing off new photos of the Land Rover on the Martian surface, scientists said they have resolved communication problems that caused them to lose contact with Pathfinder. But despite the glitches, scientists said they have already completely fulfilled all of their primary mission objectives.
We've effectively acquired all the data in the first 2.5 weeks that we expected to receive in the first month of operations on the surface.
New photos show that the 3-foot-high rock named Yogi is two-toned in color, much like an old 50s red and white Buick, as described by one of the scientists. Also shown was the path taken by the rover since moving away from Yogi last week.
It went through this region here and did some soil mechanics in this region. It went through the cabbage patch here and actually pushed some rocks around and so on.
The rover also used its probe to analyze a rock called Scooby-Doo. Greg Lamont, CNN, the Jet Propulsion Laboratory, Pasadena, California.
And on Thursday, NASA officials said they're not too concerned about a lawsuit by 3 men from the Middle Eastern country of Yemen who say they own Mars. The suit demands that NASA stop exploring Mars and quit releasing information and pictures. A NASA spokesman says Mars belongs to everybody.
Der Mars-Rover Sojourner sollte sogar nur eine gute Woche laufen, doch auch er ist noch quicklebendig, wie die neuesten Bilder beweisen. Wieder überspielte die Sonde faszinierende Aufnahmen, ein bewölkter Marshimmel in Originalfarben, Ein Sonnenuntergang auf dem roten Planeten bei minus 60 Grad. Und so sieht es aus, wenn Wind aufkommt. Alle Systeme sind in Ordnung. Wir hatten in den letzten Tagen keinerlei ernsthafte Probleme, sagt NASA-Sprecher Matt Golombek. Die anfänglichen Computerpannen sind überwunden und auch der erste Verkehrsunfall in der Marsgeschichte blieb folgenlos. Der Sojourner hatte den Felsen Yogi gerammt. Schon jetzt unvergesslich sind Computeranimationen wie diese, angefertigt aus Tausenden von Einzelfotos der Marsoberfläche. Sie zeichnet den Weg des Marsmobils nach. Im Moment sind die Batterien der Sonde halb leer, deshalb bekommt sie jetzt das Wochenende frei zum Aufladen. Wenn dabei alles gut geht, dann können die Sonde und ihr Spähfahrzeug den Mars wohl noch monatelang erkunden.
NASA's Sojourner rover is showing it can take care of itself on Mars. The little robotic wagon roamed free on the surface of Mars this week, using lasers to see and sensors to feel. It also got itself out of trouble when some gravel temporarily jammed one of its wheels. Both Sojourner and the Pathfinder landing craft sent back new pictures of the red planet. While Sojourner is going and going, scientists say Pathfinder's batteries are starting to fade. But it's still likely to last longer than originally planned.
Die größten Brocken hier sind gut 1 Meter hoch. 5 oder 6 davon hat Sojourner eingehend analysiert. Sensationelle Enthüllungen hat die Mars-Mission nicht gebracht. Nur die Erkenntnis, dass der rote Planet der Erde in manchem ähnlicher ist, als wir dachten. In Lindau am Harz treffen wir einen Mann, der die Mars-Kamera mitgebaut hat. Er freut sich, dass dort oben so viele verschiedenartige Steine vorgefunden wurden. Jeder einzelne Zeuge der gewaltigen Turbulenzen, die in Jahrmillionen auf dem Mars stattgefunden haben müssen.
Es ist nicht einfach ein Planet, wo es am Anfang einen starken Vulkanismus gegeben hat. Da sind hier die größten Vulkane im Planetensystem. Und dann ist Schluss gewesen, sondern es sieht so aus, dass eben durchaus mehr Entwicklungen, dass einige der Steine, die wir gefunden haben, dass die mehrfach aufgeschmolzen worden sind und dass eine geologische Geschichte, komplexere geologische Geschichte dahinter steckt, ähnlich vielleicht wie auf der Erde.
Natürlich könnte man den Mars weiter mit Robotern erforschen. Vernünftig wäre das und billiger allemal. Doch nun wollen Menschen hin. Das hat wenig mit Wissenschaft, aber viel mit Eroberergeist zu tun.
Wir wollen wissen, was ist Leben? Sind wir die Einzigen im Weltall? Sind wir die Einzigen im Planetensystem? Und das ist eben ein Objekt, das erreichbar ist, der Mars.
Bis dahin ist ein weiter Weg, denn vom Mars aus gesehen befinden wir auf der Erde uns ungefähr hier.
Keeps going and going. Just a short while ago, scientists from US Space Agency released the rover's latest pictures of the red planet, and they outlined what is next for the rover.
The lander operations and rover operations both have been very quiet. The rover has done a number of long traverses, as Matt indicated. We did have a problem on one of them caused by the accelerometers having a little bit of noise in them, but that was rectified, and we went on and did the remainder of that traverse the next day. So both lander and rover are operating very well from an engineering point of view, and we expect them to continue to function for many weeks, if not months to come.
The scientists say that they should be able to keep the rover functioning for another 2 months.
Die neuesten Bilder der Marssonde Pathfinder und ihres Rovers Sojourner veröffentlicht. Die Marssonde brach bislang bei ihrem Einsatz nicht nur beim Auskundschaften des Planeten, sondern auch als Attraktion im Internet alle Rekorde. Über 500 Millionen Mal haben bis zum 4. August Raumfahrtfans Informationen abgerufen. Die Batterien von Pathfinder wurden jetzt wieder aufgeladen. In 1 bis 2 Monaten soll der Rover in eine Marslandschaft vordringen, die noch kein menschliches Auge gesehen hat.
184 Bilder und doppelt so viele Daten wie erwartet hat die Marssonde Pathfinder zur Erde geschickt. Nun, nach 30 Tagen, ist die Mission eigentlich erfüllt. Doch Sojourner soll so lange wie möglich weitermachen. Als nächstes steht dem schuhschachtelgroßen Roboter ein wahrer Härtetest bevor. Er soll einen 18 Meter hohen Hügel erklimmen.
And we also took sunrise, sunset, night opacity and sky brightness measurements. We also took one super resolution, a variety of soil mechanics measurements as well. To then document what the rover's done then, if we can go to the movie, it will show first the rover's tussle with Hasek, where we actually moved the, this is just prior to getting there, this is the view of the lander. This trackball's hardly working at all. Nope, not working. Ah, okay. There you can see our famous JPL finally in view on Mars, and that kind of fuzzy thing is the American flag, but you'll have to trust me on that one. Okay, does anybody see it now? There's JPL, there's the American flag, there's the IMP, of course, the airbags and so on. Okay, the next one. This shows us entering the rock garden. This is Wedge behind us. Hassock is right behind us here. Can we show the movie? I think that should be in here. And the movie will show the rover in between Wedge on the left and Hassock on the right. It will then drive around and position the APXS up against Wedge. Any chance for the movie? Okay, I guess I can't see it. Okay, there it is. You can see the rover wheel actually moved Hassock. Here we are moving in and deploying the APXS against Wedge. Okay, next still, please.
If you want to give them a minute, why don't we cue that back up and we can take a look at it again so you can walk us through it.
Okay.
Scott, why don't you cue us back up the movie if you can very quickly, and we'll try to walk our way through that again.
What you'll see is one of the corner wheels actually... That's too fast even for me. Okay. You'll see us actually move Hassock here when we turn around. There it is. Moving Hassock. So we've moved some rocks and then moving... actually, that's up against Shark itself. That's close enough. Let's go to the stills and take you through the actual motions of the last week or so. Here we are with the APXS up against Wedge, shown here. We'll show you those results in a moment. Next still is the rear color image. This shows the APXS deployed against the rock Wedge and some of the surface texture of that rock, some of the what look like small holes and vesicles in the rough surface. Next one shows the front forward. This is one of a stereo pair. You can see it has a very rough, kind of vuggy surface with what could be vesicles or some other kind of texture in here. Looking out in the distance, then you're seeing, let's see, Shark, Half Dome, and Mo. This is Flat Top. Next one. Here we are moving around Wedge. There's Wedge there. Next one. Here we've moved in between Wedge here and Flat Top here, and the next image will show a close-up of Flat Top. Here's Flat Top. When you look closely, you do not see any of the evidence of layering that we sort of thought we might be seeing. You do see what look like small vesicles, again implying this could be a volcanic rock. And that soil line kind of just barely shows up here, implying that this is an area that has been exhumed, that there's been net transport of dust and small soil away from this region. Next one. Here we are hugging Wedge. We got so excited and we liked Wedge so much we decided to give it the old rover hug. Next one. We actually drove completely over Wedge. Here's one wheel up against Wedge. The vehicle was in no danger whatsoever. This is all within articulation hazards. None of them went off. Keep going. We actually drove completely off of Wedge and up towards Shark here. Next one. We actually turned around. I think there's one more here where we've actually placed the APXS up against Shark. This gives you an idea of what the SuperPan actually looks like, and this is really a remarkable image. It shows lossless in red and blue, lossless data for this quadrant, and it shows 2-to-1, which is almost lossless in the green. And this is pretty much true color, maybe slightly off. And when you start looking at that, you see textures in here that we just never saw previously. The last gallery pan was at 6-to-1, and we lost all of this fine stale texture that you're beginning to see in this. This is one of this product of the SuperPan, which we believe will be the penultimate characterization of the landing site from the imaging experiment, where we've taken this in 2 colors lossless, a third in stereo. Those 3 are in stereo, and then the rest 9 in 2:1, which is almost lossless. Also, just for comparison, you see here that the lighting geometry on Yogi is in the other direction, and that in this one, the blue side of Yogi is actually towards the sun. So what we showed you previously, which implied that the dust was what was producing that blue to red coloration difference on Yogi, is in fact simply a lighting geometry. We're simply looking at the sunlit side, which shows up dark, and everything else is tinged in this red from the refraction of the sunlight through this red dust-colored atmosphere with all these little dust particles in the red atmosphere, which produce the red on whichever side the sun is not coming in on. Okay, I think that's it. That sort of gives you an idea. Our long-term plans then are to continue operating within the rock garden to get the rest of those rocks. Again, we would then go counterclockwise all the way back around the lander. That will take quite a bit of time. Getting Mini Matterhorn, we would again make a stop at Mermaid Dune to investigate that further, and go all the way back to the magnetic target on the ramp that has deployed that we did exit from to get a chemical composition measurement of that magnetic dust. And finally, after that, we would then head north up that low-sloping hill to the north of the lander.
Great, thanks, Matt. How would you characterize operating the rover in the rock garden? Has this been one of the more trickier areas you've tried to operate the rover?
Absolutely. Unlike other areas where we've used waypoints and used a lot of the internal navigation capabilities of the rover, here we've had to do discrete commands. And there's been slippage and a bunch of other things that have had us going over rocks that we didn't fully expect to do.
But all lessons learned that will be used down the road.
Yes, absolutely.
Great. Dr. Tim Schofield, all the weather people out there are waiting for our next weather report from Mars. Why don't you give us a little look at what we've learned from the ASI MET package?
Okay, thank you. Here we have our traditional weather report for our 52nd day on the surface of Mars yesterday. At a time of about 2:15 in the afternoon on Mars, the heat of the afternoon.
The latest weather and the latest pictures of Yogi, Shark, Flat Top, and Half Dome, the unlikely name for a mysterious cast of characters, the rocks of Mars. We've been watching a live briefing from the U.S. Jet Propulsion Laboratory about the 3,000 images they have received now from the Pathfinder probe in recent weeks. Pathfinder and its 6-wheeled rover, the Sojourner, landed on the red planet July 4th. They have been driving around and driving over things ever since. The new images you just saw complete the emerging picture of a dusty desert landscape hundreds of thousands of kilometers away. We'll be looking more at Mars later. On Insight, we'll be examining these latest pictures and others to see what's been learned so far about the red planet. Plus, the debate over whether future Mars missions should deploy human beings or just robots, machines, and rovers. Join us for Insight in about 3 hours from now. We'll be back with world news, though, right after this.
This has been a CNN Live event.
Wispy blue clouds in the sky of the red planet, photographed by the most famous tourists in the galaxy. Pathfinder and Sojourner, still on Mars, still taking pictures. Is it time for some people to join them? Hello and welcome. No human eye has ever directly seen the sights we're about to share with you. Intriguing glimpses of a distant, inhospitable world. The Pathfinder probe and its Sojourner rover have now sent thousands of images home since landing on Mars early last month. Experts worried they might tire of the long trip, the inhospitable accommodations, or unpleasant weather, but the probe and the rover are still at it, making the rounds of the local landmarks, gathering pictures to fill scrapbooks back home. On our program today, a look at what Pathfinder and Sojourner have found, and in a moment, the debate about whether people ought to be there too. We begin with CNN's John Holman.
The news from Mars is that the clouds are blue. What a shock. Mars Pathfinder managers are also excited about the fact they have their first high-resolution pictures from the surface of the planet.
And when you start looking at that, you see textures in here that we just never saw previously. The The last gallery pan was at 6-1, and we lost all of this fine stale texture that you're beginning to see in this. This is one of this product of the super pan, which we believe will be the penultimate characterization of the landing site from the imaging experiment.
Project scientist Matt Gollenbeck says there are two distinct types of rocks now being found on the planet's surface.
Here's flat top. When you look closely, you do not see any of the evidence of layering that we sort of thought we might be seeing. You do see what look like small vesicles, again implying this could be a volcanic rock.
And for the first time in history, you can get a daily weather forecast for the red planet.
Temperatures will be normal for the time of the year, ranging from a chilly minus 103 Fahrenheit in the early hours of morning to a relatively hot and muggy 17 degrees Fahrenheit in the afternoon. We expect a 0% probability of rain.
The rover managed to move a rock as it traveled around the surface, and we even got to see a clear Martian sunset, where the sun, dropping below the Twin Peaks, looks very much like it looks when it drops below the horizon here on Earth. John Holloman, CNN Atlanta.
Joining us now to talk more about all of this is a man you saw just a moment ago and have seen a good deal of in our recent reporting, the chief project scientist of the Pathfinder mission, Matt Gollenbeck. Thanks so much for being with us, Dr. Gollenbeck, once again.
Oh, my pleasure, thanks.
Let me ask you, a whole lot of pictures have come in. You've had a lot of time to study them. The pictures are magnetic and fascinating for lay people to look at. Is there anything that we would understand that is new that you have learned because of them?
I think we're starting to see more and more of the super panorama, which is really showing us textures and fabrics that we never saw previously in these images. We have effectively lossless data in 3 colors, and actually all 9 colors and 3 stereo channels. And that's really providing a whole new scale of things that we're beginning to see in the images.
Now, it's intriguing to follow your work, to hear the news conferences, because you've named the individual rocks almost as if they were people. Are you discovering whether they have individual characteristics? Are the rocks more interesting than the rest of us might suspect?
Well, I suspect rocks are much more interesting to a geologist than they are to a layperson, because that's what we spend all our time studying and try to understand. So I'd say, sure. I mean, people spend their whole life studying rocks.
What have you found in this latest batch of pictures and the latest information?
Really, the key here has been that we have 4 alpha proton X-ray spectrometer, or chemical composition measurements of 4 different rocks, and we're seeing 2 different and somewhat distinct groups. So, you know, statistics of 1 is terrible. We have 2 that are very similar in composition. It actually gives you stronger sense that that really is 2 distinct rock types. So we think we're seeing 2 different kinds of rocks at this site. And of course, that was our desire all along, was to get a whole variety of different rock types. That's why we landed at this site.
Okay, you've been looking down for the most part, but also some pictures looking up. The sky, that extraordinary photograph of the red sky with the blue clouds that John Holloman was reporting on that struck us as well. Can you just explain that to us? Why does Mars have a red sky, and why would the clouds be blue?
Sure, the red sky is because there's quite a bit of micron or even smaller size red dust in the atmosphere, and the light hits that dust and bounces around, and so it gives it a red sheen. Now, when it's looking at the clouds, those are likely bright white ice clouds, and that effectively gives you a blue tinge because the red dust is gone from it, and you're seeing reflections in the blue rather than the red. So you're starting to see these 2 different colors in the atmosphere.
Now, taking these pictures are 1 or 2 machines that are holding up pretty well, I guess, but you would know better than anyone. How is Sojourner in particular? All of our hearts are following that little machine around the surface of the planet.
Actually, we've seen nothing in any of the telemetry to date that would indicate that we have a limited lifetime ahead of us for either the rover or the lander. We're managing the battery situation quite well. We've had no difficulties there. We actually hope to be alive for quite some time into the future.
I'm intrigued by that. When Pathfinder and Sojourner first went there was talk that really it might only last a week, all of this. Now you're saying it might be immortal?
Oh, immortal, that's a long time, but certainly months, if not a year. You know, you have to separate when the engineers design something, they have a minimum lifetime that they design it to. And in every case I'm aware of, these engineers at the lab are just so good that it lasts well beyond their expectations. So we had a minimum lifetime of the rover of 1 week and a minimum lifetime for the lander of 1 month. And now we're seeing that they're going far, far beyond that. And as I said, there's nothing to preclude us for going much, much longer into the future.
Now, sometimes, if I understand this right, computers are driving the rover. Sometimes people are sending signals to drive it. Collectively, are you getting to be better drivers? Some of the pictures we saw today suggest you're still running over things or wrapping the Sojourner around rocks.
Well, we just get excited. It's so hard not to want to hug an exciting rock like Wedge. No, people always direct the rover, but sometimes you have the autonomous controls on so that as the rover traverses and at various levels, it's keeping track of where it is and keeping itself safe. And so far, it's worked beautifully. You've seen us driving over rocks that really weren't hazards at all, and they were shut down whenever the tilt got to be too much. So far, it's operated completely within our expectations, and hopefully it will continue to.
One of the daunting challenges for Sojourner is the climate, the weather. We heard a little bit about that in John Holloman's report. But I've been reading, and maybe you could explain this to us better, that the temperature changes dramatically even if a person were up there in the space of a single pair of footprints, that at the ground it can be one temperature for your feet if you were there, and if you were standing, your head would be in almost a whole different climate.
Yeah, that's right. We've taken measurements at 3 heights in the lowermost atmosphere, and we take very short period measurements every 4 seconds. And what we find is that there's almost a 40-degree Fahrenheit difference between your feet and your nose. So your feet would be relatively warm and your head would be freezing. And we notice that within a minute, we'll have a temperature change of another 40 degrees Fahrenheit, where this little slight wind would come through and the temperature would either plummet or go up in this very short period of time. In a sense, you can think of the Pathfinder data set as being the first time you can actually kind of imagine what it would be like to be on the surface with these bizarre temperature swings and changes. We understand what the surface is like from the rover wheels. We know what our footprints would look like. We know what the rocks are like, how you'd have to jump over them. You can almost imagine yourself being there.
This from thousands of pictures, an enormous amount of scientific data of other kinds. But how big an area are you now experts on, and how much more will you learn when the next probe, the Surveyor, lands?
Well, yeah, those two are completely complementary kinds of missions. Pathfinder is a ground truth mission. The idea is to go down to the surface in a particular place and learn what it's like and what it's made of. And Mars Global Surveyor is an orbiting mission that's looking at the global remote sensing view of what Mars is about. So it will go into orbit around Mars, and it will take images and other remote sensing data to characterize the planet as a whole. And you need both of these kinds of investigations, something down on the surface to see what it's really like down there and what it's really made of, and this characterization, a more complete characterization than we got with Viking, of what the whole planet as a globe looks like.
So the adventure continues. Matthew Gollenbeck, Chief Project Scientist of the Pathfinder mission, thanks so much for being with us.
My pleasure.
The good doctor says he knows what it would be like when we come back. Will people follow Pathfinder to Mars? A look at the trip that would make Neil Armstrong's giant step seem small by comparison. Stay with us.
Drop it down. I'm going to try a little sand trap shot here. That looked like a slice to me, Al. Miles and miles and miles.
Man has been to the moon. Astronaut Alan Shepard even played golf there, hitting one of his balls an estimated 2 kilometers, thanks to the moon's low gravity. If we can play golf on the moon, why can't we send men to Mars? Welcome back. There are some people who look to the sky and yearn to travel. The success of the latest mission to Mars has ignited a debate about sending humans to the red planet. After all, we were able to go to the moon, so why not? But there are big differences between going to the moon and approaching Mars. The moon is about 400,000 kilometers away from the Earth. Traveling that distance, roughly like going from London to Los Angeles 50 times over. But at even its closest point to the Earth, Mars is still more than 100 times further away than the moon. The 1969 mission to the moon lasted just 8 days, 4 to get there, 4 days to get back. A mission to Mars would last more than a year, perhaps more than 2, and then there is the cost. In 1989, NASA estimated that a manned mission to Mars could cost more than $400 billion. Joining us now to talk about the advantages and disadvantages of trying to send men to Mars is John Logsdon, director of the Space Policy Institute at George Washington University, also the author of a book on the decision-making process behind sending astronauts to the moon. Also in our Washington studios is Robert Park, a physics professor at the University of Maryland and the author of numerous articles on experimental physics. Professors, we thank you both for being with us. If we could start with you, Professor Logsdon, it is far, it is inhospitable, it is dangerous. Why bother going there?
Well, because it's interesting. I think Mars is an object that has fascinated the human imagination ever since we understood what it was, a separate planet. It's the most Earth-like of the planets in the solar system. We had just a little over a year ago this very suggestive evidence that life might once have existed there. There is a possibility that there's still water. Human curiosity and imagination, I think, as we look out in space, focuses on Mars as the most interesting object in our celestial neighborhood.
Professor Park, are you intrigued enough to be in favor of it?
Oh, I'm totally intrigued. I think it's absolutely wonderful. The difference is I think we're already there. If I were there as an astronaut locked in my spacesuit, I wonder what else I could do that Sojourner isn't doing now. In my spacesuit, I'd have no sense of touch, no sense of smell. There's not much to hear on Mars. I'd only have my eyes. And Sojourner has better eyes than I do. I think by the time we get to where we could send a human being to Mars, we'll find the robots are doing just fine. They're sort of the natural extension of our frail bodies.
Professor Logsdon, he seems to make a good case. I mean, why bother? What more would be gained?
Well, perhaps our humanity. I mean, this is an honest difference of opinion between Bob and I, and we've talked about it before. Will the human psyche be satisfied with only sending our machines? If you ask yourself, will the human species never leave this planet again? I think very few people would say yes. And then if you say, or if I get it right, that people will never leave, very few people would agree with that. So if we say we're going to go out into space again, after all, it's 25 years since the last humans walked on the moon. It's a long time ago. If we say we're never going to do anything like that again, that to me is kind of denial of human curiosity.
Well, let me jump in for what may be one of the last times and ask you two gentlemen to talk to each other. But if we could start with you, Professor Park. To your mind, what's the biggest obstacle? And Professor Logsdon, when he's through explaining it, how would you solve it?
Well, I think actually NASA has set the right obstacles. They've said, look, first of all, there has to be a compelling need to send humans. And secondly, you've got to find a way to do it safely. And third, you've got to find a way to do it at a reasonable cost, which means at least 10 times less than the previously estimated cost. Those are pretty high hurdles to get over. And you know, it is fine to want to travel, but we are traveling. I mean, it's difficult for me to understand the difference. I like to compare the situation to the Magellan spacecraft that went to Venus. Venus is shrouded in clouds. We'll never see it with human eyes. But we have a beautiful picture of its surface taken through robot eyes. They were radar eyes that see right through the clouds.
Okay, but I'm going to jump in. Forgive me, Professor Logsdon. Let's go back to Mars, though, and is it feasible to get people there? Would a conventional spacecraft do it? Would it be possible to get enough fuel to make that enormous trip?
Sure. I mean, you, in your lead-in to this segment of the story, quoted an 8-year-old cost estimate of $400 billion, and that cost estimate killed any chance of doing the mission in 1989 or getting public support for it. As Bob says, NASA's been planning an integrated strategy for exploring Mars that for the next decade or so is totally dependent on robotic missions, but robotic missions that will begin to get the information we need if we choose to send humans, begin to see whether we can make use of the resources on the surface of Mars to make the fuel for the return journey, so we can lower the cost to 40 billion or even 4 billion. Maybe we can get it 100 times cheaper.
An intriguing point there, Professor. I'm going to jump in and ask you more about it. You're saying we'd have to get the fuel from the surface of Mars. Would it be possible, using a conventional spacecraft, to fuel up appropriately on Earth, or is that simply, even under your view of the thing, not a go?
Well, I don't know what a conventional spacecraft is. I mean, we're talking about something that's going to happen at least 10 years from now by any, I think, plausible extrapolation, maybe 10 to 15 years from now. And what we'll be able to do with our technology and what we learn about Mars from the robotic missions by then, yeah, we could launch the fuel from the Earth. We could rendezvous. I mean, there's a small group of people in Houston at the Johnson Space Center, just 10 or 12 people planning future human missions to Mars. And they have a design for such a mission that is based on, the jargon word is in situ resource utilization. That is, being able to extract fuel from the soil of Mars. But we have to go up and with the robotic spacecraft that we're going to be sending every 26 months and find out whether that's feasible before we commit a human crew.
If I understand you properly, you're suggesting there would be some kind of factory on Mars. Once the astronauts get there, that factory, creating fuel or other supplies, would help them get back. Professor Park, has anyone ever done that kind of thing? Does the experience of man in space, of Mir now, suggest that that's a good idea?
Well, it is an enormous complication. And if our interest is actually in exploring the solar system, it sets us back in time a very long way. Now, perhaps we don't want to foreclose the option of someday sending humans out there, but I think the emphasis now has to be on exploring, finding out what's there. Is there any reason for humans to go? We don't see a compelling reason right now.
Let's go back to you, Professor Logsdon. You say there is a plan. What does the plan say about the human beings and about the effect that that length of time would have on them, and how dangerous it would be for them once they got there?
Well, that's one of the reasons we're on Mir now and going to have the International Space Station, is to measure the impact of long-duration spaceflight on the human body. The reference mission for Mars talks about a 4 to 6 month outbound journey and a 3-month return journey, which is about the time that people are staying on Mir. There is an added danger once you get beyond the Van Allen belt, the radiation belt that shields the Earth from solar radiation. There are some very real dangers from solar flares, and you have to make a calculation of the risk of exposing humans to that. I mean, this is research. This is stuff we have to learn, and we're not ready today to say humans to Mars as soon as possible. There's a lot of work to be done, even if you make the almost humanistic decision that that's what you want to do.
Now, Professor, you have studied the decision-making process when it came to sending men to the moon. Did the hurdles back then seem as insurmountable or as difficult as the ones to Mars do now? Would they be equally surmountable?
Well, by comparison, the moon was easy. It's an offshore island. It's 3 days out. Kennedy was told, as he considered whether to send people to the moon, that there were no technical obstacles to the job, even though we didn't know how to get there at the time. But that was totally a political decision, using space as a symbol of U.S. competence in competition with the Soviet Union. That's not the way to go to Mars. It's not the way we should, and it's not the way we will. And I'm sure that's something that Bob and I will agree on.
Absolutely. The symbolism argument just doesn't really make any sense any longer. We need to be going there for important reasons, either of the advance of pure science or of technology. But symbolism was a part of the Cold War. That's behind us.
And we're going to go not as one nation, but as a coalition of nations. This is going to be a multilateral mission when it happens.
Well, time will tell. Unfortunately, we're out of it for now, so we have to thank you both, John Logsdon of George Washington University and Robert Park of the University of Maryland.
Thank you.
Thank you.
We will be back in a moment with a final thought about life on Mars and here on Earth. Stay with us. One last word before we go about Mars and about rocks. The Earth is hit by about 20 rocks in the form of comets or meteors every day. Virtually all of them burn up or break apart in the atmosphere. A few, though, do make it all the way. And one of those caused quite a stir last year when some scientists said it was from Mars and appeared, they said, to contain microbes that might once have been alive. Since then, there have been several other discoveries which pointed to the possibility of life in outer space. Scientists have found another intriguing meteorite from Mars, and they have seen what appear to be frozen oceans on one of Jupiter's moons. Some researchers now even say that if life once existed in that Martian meteorite, then perhaps that is how life came to Earth in the first place, maybe on a rock. In other words, if we ever do send astronauts to Mars, it may not be a case of people leaving their home planet, but of finally going back there. That's Insight for this day. I'm Jonathan Mann. Thanks for joining us. The news continues in just a moment.
These new NASA photos prove there is much more to the red planet than red. The Mars Pathfinder captured wispy blue clouds floating in a pink Martian sky lit by a golden sun. Scientists suggest the clouds are really more like clusters of frozen ice. NASA reports if all the water in the Martian atmosphere were condensed, it would form a layer around the planet just a tenth of the thickness of a hair. Meanwhile, on the ground, the Sojourner rover has found a second type of rock on Mars. These are high in sulfur content and low in silicon. The first rocks the rover examined were more like Earth rocks.
Sojourner. Einige der erkundeten Gesteinsbrocken ähnelten dem Vulkangestein auf der Erde, so die Experten. Wissenschaftler der US-Raumfahrtbehörde NASA sind optimistisch, dass der ferngesteuerte Rover noch viele weitere Erkenntnisse liefern kann.
Denn das Roboterfahrzeug Sojourner kann nun doch bis zu einem Jahr lang Daten über den Mars liefern. Konstruiert war es ursprünglich nur für eine 7-tägige Erkundungstour. Trotz erster Ermüdungserscheinungen des Gefährts glauben die Experten im kalifornischen Pasadena jetzt, dass es genügend Energie für die Erforschung weiterer Gesteinsbrocken auf dem Planeten hat. Das 6-rädrige Fahrzeug erkundet seit 7 Wochen den Mars. Seitdem hat es Sojourner unter anderem Probleme mit der Navigation und seiner Verbindung zur Erde. Zeitweise waren seine Räder blockiert.
Scientists are gaining more and more knowledge about Mars from the Pathfinder probe and its rover Sojourner. High-tech cameras are beaming back high-resolution pictures, and scientists are using the rover's alpha-proton X-ray spectrometer to figure out the composition of rocks. CNN's John Holloman has this update.
The news from Mars is that the clouds are blue. What a shock. Mars Pathfinder managers are also excited about the fact they have their first high-resolution pictures from the surface of the planet.
And when you start looking at that, you see textures in here that we just never saw previously. The last gallery pan was at 6:1, and we lost all of this fine stale texture that you're beginning to see in this. This is one of this product of the super pan, which we believe will be the penultimate characterization of the landing site from the imaging experiment.
Project scientist Matt Golombek says there are 2 distinct types of rocks now being found on the planet's surface.
Here's flat top. When you look closely, you do not see any of the evidence of layering that we sort of thought we might be seeing. You do see what look like small vesicles, again implying this could be a volcanic rock.
And for the first time in history, you can get a daily weather forecast for the red planet.
Temperatures will be normal for the time of the year, ranging from a chilly minus 103 Fahrenheit in the early hours of morning to a relatively hot and muggy 17 degrees Fahrenheit in the afternoon. We expect a 0% probability of rain.
The rover managed to move a rock as it traveled around the surface, and we even got to see a clear Martian sunset, where the sun, dropping below the Twin Peaks, looks very much like it looks when it drops below the horizon here on Earth. John Holloman, CNN Atlanta.
In the early solar system, 3 rocky planets formed of the same materials at about the same time, 4.5 billion years ago. In their infancy, Earth, Venus, and Mars were essentially alike, yet one turned into a torrid, hostile world, baking in an atmosphere of carbon dioxide and sulfuric acid. Another froze and lost all but a trace of its former atmosphere. But Earth sustained its oceans and developed an oxygen and nitrogen atmosphere, evolving into a planet rich in all of the ingredients necessary for life. What happened to our planetary neighbors, Mars and Venus, will tell us more about our own planet and what the future has in store for us. To understand them, NASA is embarking on a decade-long series of missions to Mars to answer key questions about the planet's evolution, climate, and atmosphere. The first of these missions to be launched is called the Mars Global Surveyor. In September of 1997, after a 10-month cruise to Mars, an orbiter weighing no more than 1,500 pounds will be captured in orbit around Mars. Surveyor will then begin a series of aerobraking maneuvers to lower itself into a mapping orbit just 250 miles above the planet's surface. Specially designed by Lockheed Martin Astronautics for the Jet Propulsion Laboratory, Mars Global Surveyor will rely on the drag of the planet's atmosphere to slow its speed and bring it closer to the surface. Aerobraking will take 4 months and many orbits around Mars before the Surveyor is gradually brought into a nearly circular flight path over the poles. Once there, Mars Global Surveyor will begin a 2-year mapping mission, the first intensive study of Mars over the course of an entire Martian year. Mars Global Surveyor's mission is to help enhance our understanding of Mars. Locked within its shifting sands and layered polar caps is a detailed history of the planet's climate, its weather patterns and seasonal cycles, preserved for all to see. By studying the Martian climate, we will better understand what catastrophic events sent the planet into a deep freeze millions of years ago. Those secrets can be found in the Martian landscape, in its rocks, its soil, and its ice caps, the very features that Surveyor is designed to examine. Orbiting the planet every 2 hours, Mars Global Surveyor will point its science instruments down at the surface to study the Martian atmosphere as summers turn to winters. A multi-resolution camera will photograph the entire planet, its surface and clouds, each day, as well as return high-resolution images of selected sites. These strips will be combined with altimeter measurements to create elevation maps, giving scientists valuable new insights into the forces that built the breathtaking volcanoes and immense canyons on Mars. Scientists will study the mineral composition and thermal properties of rocks and ice using infrared images. The images will also show the distribution of atmospheric dust and clouds. Other experiments are designed to explore the crust and upper mantle. The remnants of an ancient magnetic field will be charted, and the deflection of solar wind particles by the field will be tracked. As a new database of information is acquired, the mission will feed the fires of new scientific debates and perhaps lay to rest other long-standing controversies. Other countries are also engaging in this search for new information about Mars. The French are providing a radio relay system for Mars Global Surveyor that will allow the spacecraft to relay data from Russian landers on the surface. Mars Global Surveyor and another NASA mission, the Mars Pathfinder lander and rover, will both be launched in 1996 as the start of a 10-year-long program of missions to explore Mars. With multiple flights to the planet, scientists hope to answer a variety of scientific questions vital to our own future on Earth. As we begin these missions of discovery, the knowledge we gain will become the catalyst for a new educational foundation in the sciences, one that will inspire future generations to continue the journey.
Meanwhile, another NASA spacecraft is getting close to the red planet. Mars Global Surveyor is due to arrive there in about 2 weeks. It won't actually land on Mars, as Pathfinder did, but will hover above it. Global Surveyor will spend nearly 2 years mapping the planet from an orbit of about 250 miles above the Martian surface.
Now being open. There had been such high expectations. 4 years ago, the $1 billion spacecraft, Mars Observer, lifted off from Cape Canaveral, Florida. 3, 2, 1, and liftoff of the Titan III rocket with the Mars Observer. It was designed to unlock many of the mysteries of Mars. A year later, disaster. Mars Observer was lost just as it entered the planet's atmosphere. The faces of the scientists and engineers crumbled, as have the rocks on the wind-blown surface of Mars itself. But now, a chance for redemption.
A good number of us participated with the Mars Observer mission, and so this is kind of like a rebirth of the Mars Observer mission.
We have ignition, and we have liftoff of NASA's Mars Global Surveyor as America begins its journey back to the red planet.
After a launch 10 months ago, Global Surveyor is about to rendezvous with Mars. Surveyor was built in large part from Mars Observer spare parts. Because of its lineage, Surveyor is a Volkswagen Beetle of spacecraft, costing a relatively low $150 million and built in record time, 25 months. NASA hopes Surveyor will help prove the space agency's new motto, do it faster, cheaper, and better.
We got kind of used to a larger way of doing things, a little too comprehensive, too many eggs in one basket kind of a thing, trying to do everything at once.
NASA is now using a building blocks approach to Mars exploration. Each mission builds on the one before it. Surveyor's primary goal is to map the entire Martian surface and find prime landing sites for future spacecraft. Scientists say 80% of big-ticket Mars Observer's objectives will be accomplished by this bargain basement spacecraft. John Zarella, CNN, reporting.
NASA is on a roll. The Pathfinder mission continues to explore firsthand the Martian surface. And if all goes well, it will be joined Thursday by its orbiting cousin, the Global Surveyor. CNN's John Holloman joins us now with the latest on this newest mission to Mars. Hello, John.
Hi, Sonia. Right now, the Global Surveyor is about 350,000 kilometers away from the Martian surface. It's getting closer every minute, and it's traveling at 2,919 meters per second, according to the Jet Propulsion Lab. That's pretty fast, but it's going to get faster as the satellite gets closer to the gravitational pull of Mars. At this time yesterday, managers were worried the spaceship might blow up, but it got through a technically severe few minutes with no apparent problems. Up next for Surveyor, insertion into the atmosphere of Mars. NASA's Mars Exploration Manager, Donna Shirley, explains this satellite, like the Pathfinder rover, will use new technology never tried before to get up close and personal to the red planet.
The next exciting moment will be when we start doing aerobraking. And that's really tricky because the spacecraft has to fly through the upper atmosphere of Mars, just skimming through with the solar panels. If you see this model here, the solar panels flat into the flow, and that provides drag like sticking your hand out of a car window and slows it down just a little bit. And so it has to do that hundreds of times to get from the big looping orbit down into a nice tight mapping orbit that goes around the planet from pole to pole.
Takes about 4 months to do that. The purpose of this aerobraking, using it rather than using rockets to slow Surveyor's descent to its final orbit, is money. The satellite would have been too heavy to ride on an inexpensive rocket if it had used massive braking engines like other spacecraft do. Donna Shirley and her team saved $250 million by eliminating the big braking engines and using the solar panels to slow the satellite's speed. The Jet Propulsion Lab managers say the satellite is functioning normally right now. It's already provided us with some distant pictures of the planet. These were taken just a few days ago. And if it can get into the proper orbit, it'll begin sending us pictures from the planet's surface that'll be good enough to find the rover and even the Viking landers that were sent to Mars decades ago. The picture show won't start in earnest till next year, but it promises to be very, very interesting. The public relations purpose of this, Sonia, is to take those spectacular pictures, but the scientific purpose is to see what the Martian atmosphere is made of, to find out where there was or maybe is water on the planet's surface, and to figure out the best places to land on the planet with future unmanned probes and eventual human expeditions to Mars. Pretty heady stuff. Before I go, I want to show you this model to give you some sense of just how small this satellite is. This is a 1/10 scale model. And you see my hands in here. This thing in real life is only 10 times bigger than this. So this is another tiny little satellite. And if you look up at the top of it, the white area there, I think we can even show you that on another camera, you can see the brains of this. Each of these things that are sticking out of the top, a different scientific instrument that's going to tell people on the ground different things about what's going on Mars. And it's going to be a fascinating mission to watch. We won't start getting really fabulous pictures till sometime next year because it's got to go through this aerobraking maneuver to get down to the Martian surface. But after that's done, we could have some more real pretty pictures to show you, as well as some more important science, like finding out what the best place would be for a human expedition to drop in on the Martian surface.
John, when it's Mars, we always have to ask this, are they going to look for any signs of life?
Well, they don't have instruments that would see signs of life, but absolutely. I mean, if you saw something moving around down there that wasn't the rover that people on Earth sent up a few days ago, absolutely it would be able to spot those. One instrument on the top of the machine is a giant TV camera, and it sent back those spinning pictures of Mars a little while ago. And what it will be doing is looking for anything it can find up there. It's going to be going over the poles. The North Pole and the South Pole of Mars apparently have ice. If you got ice, that means you probably had water at some time, and you got to have water for life as we know it. So they'll be looking very closely in those areas to see if there are any signs of life before, or, you know, very unlikely, but maybe still going on.
Okay, John Holloman in Atlanta, thanks. And we will have more on both missions to Mars coming up on CNN's interactive program, Q&A, which airs at the times you can see on your screen now. And also CNN will keep you informed on the status and progress of the Global Surveyor beginning at these times.
Hello everyone, welcome to this edition of our program. We know from previous Q&As that many of you really enjoy discussing space exploration. Well, the issue is back in the news and back on Q&A today. CNN space correspondent John Holloman joins us for a few minutes to talk about the important new Mars mission, which is about to begin in earnest. It's known as the Global Surveyor Project. Well, John, let's start from the beginning. Basically, what is the Global Surveyor Project?
Well, it's the second of 2 satellites that was launched from Earth at the end of last year, designed to get to Mars and show us things really and truly, Riz, in anticipation of human exploration of the planet. What the folks at NASA and the other international space agencies participating on this project say is that the purpose of this is to provide the best surface map ever created of the red planet, and while doing that, to find a place for future unmanned rovers to land. But as I say, the ultimate goal is to find a place where people could land and set up shop to explore the planet's surface in person. We won't send humans to Mars until we've got a better idea of possible life support systems available there and a way to keep people alive once they get there. But this mission is paving the way. Surveyor is about 200,000 kilometers from Mars right now, traveling at about 2,900 meters per second. The next big event for Surveyor will come in about 30 hours when the satellite fires small engines and enters the Martian atmosphere. It's going to use a technique called aerobraking to get into a good orbit for picture taking. And NASA's Mars Exploration Manager Donna Shirley says it sounds complicated, this aerobraking, but it isn't.
In order to put Mars Global Surveyor onto an inexpensive launch vehicle, we had to make it real light. And so they took off the two biggest instruments. That was one thing. But even bigger mass impact was carrying along the propulsion to slow you down at the other end to get into this low mapping orbit. So the tighter the orbit, the more braking you have to do to slow down, and the more propulsion it takes, and the more mass of fuel it takes, and the bigger the launch vehicle you need to launch it. So by using aerobraking, instead of getting into this little tight orbit right away, they get into a nice big looping one that's a minimal amount of fuel, and that enabled them to launch on a Delta 7925, which only cost $50–60 million instead of $300 million like the last time we orbited Mars.
So the main reason they're doing it this way, Riz, is to save a little money. The Jet Propulsion Lab at jpl.nasa.gov has a homepage on the internet that'll show you a lot of different things. I have been fascinated by, for the past few minutes, by this particular page, which is a fuel burn that is taking place on the satellite. And although you can't see it on this version that we have on television right now, if you go to it live on the internet, it changes constantly, and you can see the fuel going down in the rocket's engines. CNN's John Zarella is at the Jet Propulsion Lab in Pasadena, and he's watching this story unfold with us.
From 2.5 million miles away, these pictures of Mars were taken by the Global Surveyor spacecraft as it approached the planet. Imaging scientists say if you think these are spectacular, just wait.
It's such a high-resolution camera. It's a big telescope that we will be looking at very high-resolution features, 100 times better resolution than from the typical Viking mission.
The clarity of the Martian images is critical because Surveyor's primary mission is to put together a global map of Mars. The detail will be crucial for rovers and landers going to Mars in 2001 and 2003.
The job of, for example, Mars Global Surveyor is to give us all the information we can possibly get about Mars so that we can understand where to land those two rovers.
The images from Global Surveyor won't be used simply to determine where robots of the future go. The pictures will help planetary scientists decide where the first human expeditions should land.
Mars Global Surveyor is really what's going to tell us, hey, is there a Yellowstone Park here? Or is there a really neat canyon? Or was there a lake bed here at one time? And that information is going to help us not only with our future Mars robotic exploration, but get us ready for human missions, because we don't want to send humans all the way to Mars and have them go someplace dull.
Ideally, the first humans will land at a spot on Mars where water once flowed. Water is a key to finding life. And Global Surveyor will, the experts say, pinpoint areas where water once existed and where life might have evolved eons ago. John Zarella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
Big question. A lot of our viewers have had, Riz. Remember that face on Mars that these scientists talked about years back? This thing will go there. It will fly over it. It will provide some good pictures of it.
You just answered that email which said, will Surveyor cameras also focus their attention to that mysterious Martian face, Klaus in Germany? Now, are they going to learn anything else from that, though?
Yeah, they're going to learn so much from these pictures compared to the earlier pictures that the Viking probes showed us of Mars and the Hubble Space Telescope pictures. Let me show you our model of the Surveyor. This is what it looks like. The real one doesn't have the long pole at the bottom or the wooden stand, but it looks the same in every other way. These are the science instruments on the top. There is a camera up there, much more sophisticated than any camera that's ever been to Mars. The solar panels here will allow it to slow down as it's entering the Martian atmosphere and do its work once it gets there. But the pictures that will be made and the scientific data gathered by those instruments up on the top, the white instruments on our model, will be vital to determining things like what's the atmosphere like, such as it is, things like that.
You know, they had to film that on the set earlier because they were worried you'd knock me unconscious if you brought it in.
Well, it is, I mean, it's about this wide, as our viewers that were here a while ago know, and it's a 1/10 scale. So this real thing, the real satellite, is only about like this. I mean, it's kind of like the rover, which will fit on our desk.
Considering that size, John, you've partly answered this fax question we got. It was from Daniel Fischer. This came from Germany. It says, what is the main advantage of the Mars mapping by the Mars Global Surveyor camera over the excellent Mars maps we got from the Viking missions of the 70s?
Well, these maps will be newer. These maps will be clearer because the equipment is just better, the camera is better, and the way that they're going to send the information back to Earth is quicker. We'll get it sooner. It will probably be much higher fidelity, might even be 3D. And what they'll be able to do then is build a relief map of Mars. Next time we talk, I'll bring my little Martian globe, which is about this size, and it's very fuzzy. The globe that they'll be able to create after this mission will be crystal clear. I mean, you'll be able to look down into the riverbeds and things.
Oh, John, it seems Earthlings have gone Mars crazy. We're going to talk about this with you, I know, in the future, but we've got to end it there. We've run out of time with that one.
All right.
Great to have you on the set again.
Same here, Riz.
Thanks. So we have to say goodbye to John for now, but up next, NASA Mars scientist and Pathfinder expert Matthew Golombek will join the Q&A forum from the Jet Propulsion Laboratory in Pasadena, California. He'll tell us how the Mars Pathfinder mission is moving along and take your questions and comments. Stay tuned for that. We're coming right back. For an updated list of future show topics and guests, be sure to check out the Q&A webpage. You can access it via the internet at cnn.com/Q&A. Welcome back to the show. We've been talking about the Mars Surveyor mission. NASA scientists are preparing to get the first bit of information from Surveyor back to Earth. But there's another Mars expedition, one that's already delivered to us valuable information about Mars and, of course, incredible pictures of the Red Planet too. I'm, of course, talking about the Pathfinder mission. To talk about that project and the planet Mars, I'm pleased to have with us NASA's chief scientist on the Pathfinder project, Matt Golombek. Matt, thanks for being with us.
Oh, it's a pleasure.
Well, let me begin by asking you, we've just heard about what Surveyor is expected to do, but what effect might the Surveyor mission have on Pathfinder or on future Pathfinder-type missions? How is it going to affect one going to affect the other?
Well, I mean, immediately, in the immediate future, none, really. It takes them a while to get into a mapping orbit. Once they do, however, there are synergistic science experiments that you can do where you have Pathfinder looking up at the atmosphere at the same time that Global Surveyor is looking down. And that allows you to separate out the lower part from the upper part and so on. And so we actually have planned a variety of synergistic science campaigns after MGS gets into orbit.
We had a fax question for you. Our email was slow in coming in, unfortunately, because of technical problems, but we did have a fax question for you from Germany. It said, how will Surveyor's data influence the transmission times of data from Pathfinder?
Not directly. If anything, we do pretty well because the deep space antennas that are tracking MGS will also be tracking Pathfinder. And so we'll be sharing data antennas, and we actually, for quite some time, until they get into mapping orbit, we'll get as much antenna time as we want.
All right, a caller from Germany with a question for you, Matt. Go ahead, caller in Germany.
Yes, hello. First, I'd like to congratulate the team for your great mission. And I've read in the paper that instead of using too much digital technology for the Sojourner, you reverted to more sturdy, already tried technology, which I welcome. Is that a trend or an approach that we can expect to see in the future for future Mars missions?
I think it depends. What we did with Pathfinder is we had a fixed budget and only a certain amount of money that was in it, and we knew we couldn't spend more. And so we looked for things that existed on the shelf that we could use as they were to sort of minimize the cost. And so we used a very primitive computer, central computer that was already radiation hardened and tested, and so on. And so in a lot of cases, we did use not the latest things. In other cases, where we needed that, we definitely developed new technology. The aerogel used to keep the rover warm, for example, is a completely new technology that we took advantage of here at the lab.
And yet, Matt, it could be that the simplicity is what has kept this Pathfinder mission going much longer than many people expected.
Well, I always expected it to last a really long time. You know, the engineers designed it for a minimum of a week for the rover and a minimum of a month for the lander. But there's really nothing that we expected that would go bad for months, if not a year. And as I've been telling everyone, I hope to have this job for a full year in time.
A fax question from Thailand. This one actually is a question a lot of people have been asking. Is it worth it to invest billions of dollars annually in the name of scientific research?
I mean, that's a general question. I'll just take the part that I know about, which is the Mars exploration program. And we're doing these missions at the cost of what a major motion picture costs. It cost Pathfinder, it cost us less to get Pathfinder built and launched than it did to produce the motion picture Waterworld. And I think for that kind of cost, that kind of nominal cost, and the exciting results that we can provide to the people of the world, it's well worth it.
I was going to say, dare I say it, some say it's more entertaining and it seems to have lasting value. What will you learn from it, though? I mean, how far are we off using the information to benefit us directly?
Well, I mean, I don't think you can look at the Mars exploration program, the unmanned program, as a way to, what kind of things are you going to get back that's going to directly affect our economics here on the Earth. You have to look at it as, what will we learn that will inspire people? What will we learn about our place in the universe, our place in the solar system, how the Earth and Mars are similar or different, and so on. It's not about, is there an economic payoff? It's about, what can you do to completely open up your mind and learn about something that's so interesting but different from what you deal with day to day?
Now, how much inspiration has come from Pathfinder? How much has the approach to the research on Mars and space missions changed because of the success of Pathfinder?
I can't tell you, I've gotten hundreds and hundreds of letters and emails about people just saying how excited they were from kids who now really want to get into science and math and learn about technology and even want to become geologists. I mean, that's terrific. That's the kind of energizing that occurred in the Apollo era, when we had this big influx of math and science PhDs in response to the space exploration program.
At that time, Matt, we saw a lot of work done by the US and by the Russians. Now, to what extent, with Mars exploration, has the United States become the sole explorer of the Red Planet?
Well, I mean, I hope that's not the case. Even with Pathfinder, we had significant contributions from the various German agencies and institutes in Germany. The Alpha Proton X-ray spectrometer was provided almost entirely by Germany, and a big chunk of the camera was provided by them at no cost to us. So I think you have to use the cost-sharing approach, where you provide, things together to give you a better result, a cheaper product, too.
All right, well, the Red Planet's our focus on Q&A today. We want to know what you think. Join our interactive forum. When we get back after this short commercial break, we'll be talking once again to Matt Golombek from the Jet Propulsion Laboratory in Pasadena, California. Stay tuned. Welcome back. Before we return to today's show, a quick look at what we have planned for you tomorrow. The Amazon and its power to heal. Our guests spent 4 months in the Amazon basin documenting and photographing the wildlife. What they learned amazed them, and it'll amaze you too. You can start by sending in your questions or comments now by fax or email. The email address is cnni@turner.com, and the fax number is 1-404-827-4056. Hope you're going to join us for that show tomorrow. For now, though, it's back to today's show. We're talking about Mars. We've not got a lot of time left with our guest, Matt Golombek, so let's get right back to questions. And Matt, a question for you. I'm curious, what area of research would you personally want to see done on Mars?
Well, I have a whole research program that I do myself, and I'm actually looking forward to really getting my hands into the Pathfinder data. We're receiving just gobs and gobs of data, more than we can actually look at in a timely fashion right now. And we're really hoping to build up a data set that will last for tens of years for analysis by scientists around the world.
A caller from India has a question. Go ahead, caller.
Now that it's this is a question, Mr. Golombek. Now that it's apparent that there's no life on Mars, what is the likelihood of another mission, and when is there likely to be one?
Well, we don't know whether there's life or not on Mars. We certainly have not found anything obvious at the Pathfinder site, but of course we weren't really looking for it. It is possible that in very selected niches where there's liquid water in a hydrothermal system underground away from the UV radiation, that you could potentially still have life. But I suspect most scientists would say that's a remote possibility. We do have a long-term Mars exploration program because, to me, the issue isn't whether there's life there now. It's whether life could have started on Mars 4.5 billion years ago, when the evidence indicates that life started on the Earth. And the evidence also seems to indicate that Mars may have been warmer and wetter at that time. And so here's your neighboring planet right next door in the solar system, and we can go there and we can look to see whether the environment was similar and whether life could have gotten started. You know, will life form anywhere that liquid water is stable, or do you need some very special, I don't know, divine intervention to have that happen? And that's such a compelling question. I think that's something we should definitely try to do.
You made an interesting point. You said we haven't gone looking for life yet. I know all our Hollywood films show us with life on Mars looking for us. But as far as looking for life on Mars, is there going to be any plan to look that much deeper into that kind of issue?
Well, I think so, but what I was trying to get at is that we shouldn't be looking for it now. What we should be doing is looking at the ancient environment on Mars to see whether or not life could have started or not. That's really almost the more fundamental question. We're not talking about little green men on Mars. We're talking about primitive bacterial life somewhere in some ecosystem that's buried beneath the ground. That's very difficult to find. Let's go to a place where we can tractably look at that problem, say an ancient lake basin on Mars where water was stable early on in its history, and see whether the environment was right and whether life formed way back when. And then if we learn that things did start then, maybe starting to narrow it down about looking for it in these specialized niches.
Bosnia's on the line with a question. Go ahead, Bosnia.
Please, could you tell me when you expect that first man will come to the planet Mars?
Well, I don't know. That's a political decision about when you send people. And I'm just a geologist working on a robotic mission here. I think eventually people will go to Mars because you can maybe make the analogy with the discovery and the work in Antarctica before you actually got to the South Pole. Eventually, the technology will improve to the position where people will want to go for some reason or another, and people will go there. And all I know is that when they do, it's a really good thing to have these robotic missions beforehand so we can really send them to interesting places where they can do really neat science.
Probably a silly question, Matt, but would you want to go up there yourself?
I don't think I would. I'm pretty happy here on Earth.
Let me ask you about the other aspect of space that's being talked about is the space station, having a huge space station orbiting outside Earth. Now, how much is that going to have an impact on research to planet like Mars? Is it going to make a big difference to the way you do your work?
No, I don't think so. I mean, the space station doesn't look at Mars. It doesn't have anything there. The Hubble Space Telescope does provide data, of course, at very nice resolution.
I was thinking more in terms of as a launch pad for missions out. I mean, a lot is talked about the difficulty of getting, you know, vehicles out of the Earth's orbit and so on. You'd have an easier launch point, so to speak.
Sure, I think that has to do with whether you send people or not, and that's really too far in the future for me to look at. Not for robotic missions. It's pretty easy just to put them on a expendable launch vehicle and get them there straight away.
Now, how much does the success of missions like Pathfinder give a big financial boost to NASA? How much is NASA's position stronger in saying, well, let's try this, let's try that, we've got the money now because we've proved ourselves?
I mean, I can't hurt. I mean, getting people interested and excited about the space program is only a plus. And if Pathfinder's done that, then I'm all for it.
Now, is Surveyor going to have an impact on that too?
I would certainly hope so. I mean, all of us scientists are, you know, praying that it performs spectacularly and returns just this wonderful data set that we can look at for another 10 or 20 years.
I don't know if we got onto a specific date for a future Pathfinder 2 type of mission. Is there anything in
Oh, well, we do know what the long-range plan for Mars exploration looks at. And its goal is to answer this fundamental question of whether life could have started on Mars early on. Now, in '98, we have an orbiter and a lander, neither of which looks like either Surveyor or Pathfinder. They're very different. The lander will go to the South Polar layer deposits and scrape away at the ice and the dust there to try to learn about climate change, of obviously very important topic. And then in '01, we're talking about a long-range rover like the one you saw earlier that would scurry kilometers across the surface to try to learn more about different formations and the history of Mars.
Let me squeeze in a quick call from Israel. A quick question, please. Caller in Israel.
Yes, my question is simple. Wouldn't it be more scientifically productive to put in the coming future, 10 to 20 years, to put an object in orbit around the planet with a few people inside and just send a bunch of rovers down? Won't these rovers beam up more information than a human mission landing on the planet?
A brief answer to that, please, Matt.
That's a very interesting question, and there's been quite a bit of work in the virtual reality of actually having people operate these rovers in semi-real time, where you actually get inside the rover and operate it. And that's a very interesting prospect, and that's been suggested by various proponents of advanced missions to Mars. And I think that's something that we'd really have to consider, you know, whether you'd want to keep the people in orbit and have a direct link to the rover that would then go and operate in a more human fashion, if you would.
Well, Matt, I'm afraid we're out of time. Q&A doesn't last as well as your Pathfinder mission, I'm afraid. We don't have as much time. Thank you very much for being with us.
You're welcome.
Matt Golombek of the Jet Propulsion Laboratory joining us there. Thanks for sending in those questions for him. Thanks to John Holloman for joining us earlier with his look at the Surveyor mission that's coming up. And do send us those email and fax questions for shows ahead. You can check the web to find out what's coming up. Hope you'll be with us tomorrow for another edition of Q&A. Stay tuned. There's much more coming up on CNN.
From 2.5 million miles away, these pictures of Mars were taken by the Global Surveyor spacecraft as it approached the planet. Imaging scientists say if you think these are spectacular, just wait.
It's such a high-resolution camera. It's a big telescope that we will be looking at very high-resolution features, 100 times better resolution than from the typical Viking mission.
The clarity of the Martian images is critical because Surveyor's primary mission is to put together a global map of Mars. The detail will be crucial for rovers and landers going to Mars in 2001 and 2003.
The job of, for example, Mars Global Surveyor is to give us all the information we can possibly get about Mars so that we can understand where to land those two rovers.
The images from Global Surveyor won't be used simply to determine where robots of the future go. The pictures will help planetary scientists decide where the first human expeditions should land.
Mars Global Surveyor is really what's going to tell us, hey, is there a Yellowstone Park here? Or is there a really neat canyon? Or was there a lake bed here at one time? And that information is going to help us not only with our future Mars robotic exploration, but get us ready for human missions, because we don't want to send humans all the way to Mars and have them go someplace dull.
Ideally, the first humans will land at a spot on Mars where water once flowed. Water is a key to finding life. And Global Surveyor will, the experts say, pinpoint areas where water once existed and where life might have evolved eons ago. John Zarella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
The Global Surveyor will begin slowing itself down in just about a day, and that process will be a crucial moment of truth for NASA's latest Martian explorer. CNN's John Zarella is at the Surveyor Command Center, the Jet Propulsion Laboratory in Pasadena, California, and he joins us now. John.
How are you, Sonia? Well, I'm actually standing outside here in what's called the Mars Yard. And this is where NASA tests all of its robotic vehicles of the future. It lets them roam over these rocks here to test their wheels and make sure that they can climb over what would be a landscape on Mars. And these images were actually, what this setup is from the images that were taken from the Viking landers 20 years ago. Now, the Mars Surveyor is going to get images that are far more spectacular and detailed than anything ever seen before. And that's going to come pretty soon when it arrives at Mars. Coming back are said to be so good that the maps of Mars will likely be better than any maps we have of Earth. Now here joining us, Donna Shirley. Once again, Donna, back. A couple-month hiatus since Pathfinder, but Global Surveyor, all is going well, about 30 hours maybe till you enter Mars atmosphere?
Mars orbit, yeah. Yes, everything's going very well. We pressurized the tanks yesterday, which means that the whole system is all ready to go, ready to burn the engine, ready to go into orbit at 6:30 Pacific time tomorrow.
We were talking in the piece that one of the primary missions is the mapping, and ultimately we have a rover here, Rocky 7, which we're looking at, and it's really going to help decide where to send rovers like this in the future, isn't it, this mission?
It is. Yes, it is. The Mars Global Surveyor images will actually be able to see things the size of a car and little postage stamps around the planet, and then the global images will really help us understand the planet, know where to send the rovers, and then these rovers are much more sophisticated than
and Sojourner.
I was going to say, this one here has the capability to pick up things, and you're leading up, of course, a gradual build-up to when you're going to do sample return.
That's right. We're going to send a rover in 2001, which will be based on Rocky 7 here, and another rover in 2003 that will actually travel 10 kilometers or so over the surface, collect rocks, and put them in a box for return by the sample return mission that launches in 05 and gets back to Earth in 08.
I think one of the fascinating things is you have a model, a small model here of Global Surveyor. One of the fascinating things, we're talking about these spectacular images. How are we going to get them? Where on this vehicle?
Well, this little camera right here, this is a 1/50th scale model, so it's very tiny, but this is actually a large telescope, and this is going to be taking these very high-resolution pictures as well as in a low-resolution mode, mapping the planet every day like a weather map that you see on CNN every morning.
So what we're going to have, though, is this tremendous image, an entire map of the surface.
Right. We'll have a map of the surface at medium resolution, better, you know, about as good as Viking, but then we'll have pieces of the surface that are very, very high resolution so that you could see Pathfinder on the surface, for example.
And Donna, one last quick question then. Excitement really starting to build for this team?
Absolutely. This team was there for Mars Observer, the failure of Mars Observer, and they are going to do it right this time for sure. And they've already gotten through all of the stuff that went wrong with Mars Observer, so I think it'll be a piece of cake tomorrow. I'm real optimistic.
Donna, Shirley, thanks once again for taking time to join us. Talking about Mars Observer, one of the things about this vehicle, of course, was that it was really built in some large part from the spare parts of Mars Observer, which failed about 3 years ago before it actually made it to Mars. So it was a very inexpensive vehicle and was put together in record time, and at record low costs. This is a wonderful experience, again, to be here at the Jet Propulsion Laboratory, waiting once again for NASA to arrive at Mars.
Okay, John Zarella at the Jet Propulsion Laboratory, thanks. And CNN will begin its in-depth coverage of the status and progress of the Global Surveyor, beginning at the times you can see now on your screen.
And in Newsroom Worldview, an unmanned U.S. spacecraft is on the mission. It is entering the red planet's orbit around 10 p.m. Eastern, 0200 GMT. Well, these pictures were taken by the spacecraft as it approached Mars from 2.5 million miles or 4 million kilometers away. Its goal is to send back the most detailed images ever of the Martian surface. And it's different from this summer's Pathfinder mission, which landed on Mars to gather geological information. Pathfinder was the first U.S. landing on Mars since the Viking spacecraft in 1976. Well, the Global Surveyor will gather information that Pathfinder can't. All that without ever touching the surface. John Zarella has more.
To prove whether life ever existed on Mars, or perhaps still does, evidence of water, past or present, must be found.
We have ignition, and we have liftoff of NASA's Mars Global Surveyor as America begins its journey back to the red planet.
Looking for signs of water, the key ingredient in life, is one of Global Surveyor's primary goals. It was launched last November, the first of 2 probes destined for Mars. The other, Pathfinder, passed Surveyor en route and landed on Mars July 4th. Pathfinder was a tremendous engineering feat, and images of the Martian surface mesmerized the world. But planetary scientists say it is Surveyor that may rewrite history.
This mission will return more data than all of the planetary missions to Mars in the past have ever returned.
I think there'll just be an explosion of the things we know. To a certain extent, we think we know quite a bit about Mars now, based on the Viking, but probably a lot of the things that we think we know are wrong.
Unlike Pathfinder, Surveyor will not land on Mars. It will go into orbit around the planet and sample the Martian atmosphere. It will take about 6 months for Surveyor to get properly aligned above Mars. Then it will begin 2 years of mapping the entire Martian surface. Project scientists say when they're finished, the Mars maps will be more precise and detailed than those of Earth. High-resolution cameras will send back wide-angle and close-up pictures from cloud cover to ancient river channels.
We're going out there to make a survey of the planet, to understand the resources and understand what's there all over the planet. In that process, we'll be able to identify areas that might have been conducive to past life,
Where future robotic missions land will in large part be determined by studying the data and images sent back by Surveyor. Ultimately, the first humans to walk on Mars will likely land at a place chosen from Surveyor photos. John Zarella, CNN, reporting.
NASA is about to begin its newest mission to Mars. A satellite, the Global Surveyor, is expected to maneuver into an orbit of the red planet within hours, and in a few months it will begin mapping the Martian surface from above. This new probe will begin its work as the rover Pathfinder, its batteries running low, finishes what has been a very successful mission. CNN's John Holloman looks back.
The excitement of Pathfinder and the little rover that could is best expressed in pictures. This picture, the monster pan of the Martian surface, was the clearest shot ever taken of another planet transmitted to Earth. And during the 2 months it's been there, Pathfinder has shown us a lot.
You'd be standing on the surface, you'd see temperature swings of 40 degrees between your feet and your nose. your feet being warmer, your nose being colder. And within a minute of standing there on the surface, you'd feel another 40-degree temperature swing as this little eddy of wind came by and changed the temperature dramatically. You can imagine from the rover wheel treads that, you know, what it would be like to have your footprints in that light red soil where you'd pick up this deeper red underneath it.
And project scientist Golombek says for geologists, the first big discovery was that this area was caused by a flood of biblical proportions. And then there are the rocks, named for cartoon characters. The first one investigated, Barnacle Bill by name, shocked the scientific community on Earth.
What we're seeing is that both Shark and Barnacle Bill have very similar compositions, and they appear to be distinct from Yogi and Wedge. And so it looks like we have two different kinds of rocks on Mars. And of course, that's what we were hoping and praying for with this landing site, was to get a whole variety of different kinds of rocks.
In recent days, Pathfinder's batteries have gone dead, but its solar panels still allow it to send pictures like this back to Earth, though they're coming more slowly than when the science mission started in July. John Holloman, CNN Atlanta.
If you ask any UFO aficionado about the Mars face and then stand back, a whole slew of theories are sprung up about a rock formation on Mars that looks, well, sort of human. Well, believers call it the Martian version of the Great Pyramids. Scientists call it a rock. The satellite Global Surveyor goes into orbit around Mars in a matter of hours and may help to put that issue finally to rest. CNN's John Zarella reports.
More than 20 years ago, the Viking spacecraft orbiting Mars took this picture as it photographed the surface of the red planet. Since then, the single image has become known as the face on Mars, and it has generated a controversy that won't go away.
The proponents say it was something left by a past civilization. Other people have suggested that it's a trick of light and shadow. We don't really know. I don't think anybody really knows. I myself would like to know.
Now there's finally a chance the debate will be over. During the next 2 years, the Global Surveyor spacecraft will, from its orbit, photograph the entire Martian surface. The images will be 100 times clearer than those taken by Viking. The face will either look a lot more like a face or simply a clump of rocks. But Global Surveyor's imaging scientists warn there's no guarantee they'll get the picture.
At the rate the spacecraft moves, which is like 3 kilometers per second, we're only over an area for a second or two before it's out of our field of view. So the likelihood of our being able to take a picture of any given feature on Mars is very small.
If Global Surveyor can't produce a clearer image of the face on Mars, no explanation from NASA will be good enough to silence those who believe it is more than simply a trick of light and shadow. John Zarella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
CNN's coverage of the Global Surveyor mission starts Thursday at the times on your screen.
Surveyor is just about to enter orbit into Mars. Joining us now, live from the Jet Propulsion Laboratory in Pasadena, is CNN's John Zarella. John.
Leon, we're at the Von Karman Auditorium here where the lights are coming on and they're preparing for a very happy post-news conference in about 10 minutes. Just a few minutes ago, they got the final word from NASA, from the spacecraft, that all had gone well. The burns had gone well. They were getting back information from the spacecraft. It's healthier than they even expected it would be. It is now orbiting around Mars. You can hear the cheers from the control center in Denver. That's the Mission Control Operations Center, and from the mission team here in Pasadena. They're all wearing red hats. That's their global surveyor hats that they're wearing. And this is really another tremendous success for the U.S. space program, following closely on the heels of Pathfinder 2 months ago. Now, for about the next 4 months, this vehicle is going to continue to spin around Mars as it circularizes its orbit, and then it will begin the mapping mission, which will be sending back some of the most sensational pictures of Mars ever taken. And we'll all, of course, be waiting for those. Again, success here at the Jet Propulsion Laboratory. Leon.
John Zarella, thank you very much indeed on that successful note. That's it for World News. Stay tuned. We've got Showbiz Today.
Through its second big test, the Jet Propulsion Laboratory in California was all smiles a short time ago as the Mars Global Surveyor sent back signals indicating it was in orbit around Mars. It came after the craft fired its main rocket, slowing it down enough to circle Mars, and soon will begin taking high-resolution pictures. Officials say they expect the Global Surveyor to start transmitting photographs in about 5 days.
They have taken a major step toward a possible manned mission to Mars. And it's all because of a small robotic spacecraft that traveled 700 million kilometers in the last 10 months. CNN's John Zarella explains.
The wild applause gave it away. NASA is 2 for 2. Late Thursday evening at Mission Control in Denver and at the Jet Propulsion Laboratory in Pasadena, engineers and scientists cheered and celebrated.
You guys did a great job, and we're just really tickled pink here.
For the second time in 2 months, a U.S. spacecraft has arrived successfully at Mars. Pathfinder is on the ground, and Global Surveyor is now circling overhead.
This is the first spacecraft, of course, in 20 years, the first U.S. spacecraft in 20 years to be in orbit around the red planet. And we can say, hello, Mars, we're here to stay, and we're here to stay for a long, long time.
NASA's associate administrator thanked the team that built Surveyor.
For building it cheaper, building it faster, building it on time, building it under budget, and delivering it safely to Mars. My hat is off to them.
Global Surveyor dove into orbit around Mars as it passed over the planet's north pole. During this period, Mission Control was out of contact with the vehicle. Seconds after it emerged from behind the red planet, Surveyor phoned home. It was in orbit. The drama being played out 435 million miles away is only just beginning. For the next several months, Surveyor will perform a risky maneuver called aerobraking. On each of the next 400 revolutions around the planet, the spacecraft will skim the atmosphere, using friction to slow it down.
Aerobraking is no picnic. I mean, aerobraking is something we've never done before at Mars. We have to skim through the atmosphere just right each time, just taking a tiny whisker of energy out so the orbit gets smaller and smaller and smaller. And that's going to be a real exciting process because the atmosphere of Mars isn't nice and smooth. It plumes and it goes back, and so it's going to be real exciting.
Once the aerobraking is completed, Surveyor will be in a perfectly circular orbit. And before much longer, its cameras will start clicking away never-before-seen images of the Martian landscape. John Zarella, CNN, at the Jet Propulsion Laboratory in
Der NASA. Nach 700 Millionen Kilometern Flug sollte die neueste Forschungssonde der Amerikaner endlich an ihrem Bestimmungsort ankommen, sofern die Berechnungen stimmten. Objekt der wissenschaftlichen Begierde, der Mars. Seit dort erste Hinweise auf Mikroorganismen, also auf Leben, festgestellt wurden, hat der rote Planet die Forscher in eine wahre Euphorie versetzt.
The spacecraft is now emerging from behind Mars.
Alles lief nach Plan. Erleichterung in den Kontrollzentren der NASA in Pasadena, Kalifornien und Lockheed Martin Denver, dem Hersteller des Surveyors. Die von der Fähre empfangenen Daten signalisieren, Surveyor hat das erste schwierige Manöver erfolgreich durchgeführt. Gratulation an die Aeronauten am Boden. Ihre Berechnungen stimmten exakt. 700 Millionen Kilometer legte die Fähre von der Erde bis zum Mars zurück. 10 Monate dauerte die Reise. Die Mission soll neuen Aufschluss darüber liefern, ob es Leben auf dem Planeten gibt oder zumindest einmal gegeben hat. Beim Anflug musste das Raumschiff mit voller Maschinenkraft 22 Minuten bremsen, um sicher in die Atmosphäre einzutauchen. Das Manöver steckte voller technischer Risiken. 1993 scheiterte daran eine ähnliche Mission kurz vor dem Ziel. NASA verlor einen Marsbeobachter, internationales Ansehen und hochfliegende Hoffnungen. Das Unternehmen Surveyor ist bescheidener und billiger als vorherige Programme. Zunächst umfliegt die Fähre Mars in Ellipsen, um im Laufe der nächsten 6 Monate Kurs auf eine nahe Umlaufbahn zu nehmen. Dann fotografiert Surveyor die gesamte Oberfläche. Das dauert ein Marsjahr lang, 687 Tage. Mit den Aufnahmen analysieren Wissenschaftler das Marsgestein und erstellen schließlich eine genaue Karte des Planeten. NASA dämpft allerdings eine weitgehende Erwartung: Spuren von entwickeltem Leben seien auf dem Mars nicht zu finden. Allenfalls neue Hinweise auf Mikroorganismen. Surveyor ergänzt die Pathfinder-Mission. Seit dem 4. Juli erkundet Pathfinder ein kleines Gebiet der Marsoberfläche und schickt Bilder von bis dahin unerreichter Qualität. Der Verlauf beider Projekte für die NASA ein Ansporn. Zum ersten Mal seit 20 Jahren umrundet ein US-Raumschiff den Mars. Diesmal können wir sagen: Hallo Mars, wir sind da, wir werden lange bleiben. Zuversicht bei der NASA, dass Surveyor auch seine weiteren Aufträge erfüllt. Die roten Kappen symbolisieren, die Mission geht voran. Wir haben alles unter Kontrolle.
They're cheering in Mission Control in California. Man could be a step closer to walking on Mars. Here to tell us all about that, CNN's John Holloman. John?
I call it a good news, bad news story, Jim. We got good news on Mars, bad news on Mir. Global Surveyor did exactly the right thing about 12 hours ago and entered a perfect orbit around the surface of the red planet.
Erreicht die Marssonde Global Surveyor heute die Umlaufbahn des roten Planeten. Bei der NASA wurde der Erfolg entsprechend gefeiert. Anders als das Marsmobil Pathfinder wird der Global Surveyor nicht auf dem Mars landen, sondern ihn nur umkreisen. In dieser Zeit wird die Sonde detaillierte Karten vom roten Planeten anfertigen. Außerdem sind Untersuchungen der Atmosphäre und des möglichen Magnetfelds vorgesehen. Global Surveyor ist nach Ansichten von NASA-Experten ein wichtiger Schritt zu bemannten Mars-Missionen in der Zukunft.
Bei der Erforschung des Planeten Mars ist die NASA einen weiteren wichtigen Schritt vorangekommen. Die Raumsonde Global Surveyor ist heute erfolgreich in eine Umlaufbahn des roten Planeten eingeschwenkt. Die Wissenschaftler hoffen jetzt auf detaillierte Fotos und Daten von der Marsoberfläche. Aus den USA berichtet Christoph Lang.
Wieder feiert die NASA einen großen Erfolg, denn auch die zweite Mars-Mission in diesem Jahr läuft wie geschmiert. Nach 10-monatiger Reise und mehr als 700 Millionen Kilometern stand heute Nacht ein heikles Bremsmanöver an, das die Sonde Global Surveyor in die Mars-Umlaufbahn katapultieren sollte. Vor 4 Jahren war eine andere US-Sonde dabei verloren gegangen, doch diesmal ging alles glatt. Die Erleichterung war groß. Hallo Mars, das sind wir, freut sich Projektmanager Cunningham, und wir werden eine ganze Weile bleiben. 2 Jahre lang wird der Global Surveyor den Mars umkreisen und dabei mehr Daten sammeln als alle bisherigen Mars-Missionen zusammen. Er wird die vor allem aus Kohlendioxid bestehende Atmosphäre untersuchen, Staub und Wolken ins Visier nehmen. Und er wird vor allem eine faszinierend detaillierte Karte der Marsoberfläche mit ihren Schluchten und Gebirgen erstellen. Bis auf 1,5 Meter genau soll sie sein. Der Surveyor kommt zur rechten Zeit, denn unten auf dem roten Planeten machen beim Marsmobil Sojourner schön langsam die Batterien schlapp. Schon jetzt gilt diese erste Mission als großer Triumph für die NASA, nicht zuletzt wegen Bildern wie diesem Sonnenuntergang.
Nach den Erfolgen des Erkundungsroboters Sojourner schaffte jetzt eine neue US-Raumsonde den langen Weg zum roten Planeten. Surveyor heißt sie und soll von ihrer Umlaufbahn aus den Mars unter die Lupe nehmen.
Für einen Augenblick hielten die NASA-Experten den Atem an. Dann zeigten die Computer,
Der Global Surveyor hat es geschafft. Er beginnt seine Umlaufbahn um den Mars. Seit 10 Monaten war die US-Sonde unterwegs und hatte 700 Millionen Kilometer bis zum roten Planeten zurückgelegt. Mit Spezialkameras und Messinstrumenten soll der Surveyor aus 375 Kilometer Höhe den Mars erkunden und dabei auch nach Spuren von Leben suchen. Infrarotstrahlen sollen den Boden analysieren. Die Oberfläche des Planeten war vor 3 Milliarden Jahren zum großen Teil mit Wasser bedeckt. Ab März nächsten Jahres wird die Sonde die Marsoberfläche detailgenau fotografieren, um auch künftige Landeplätze zu erkunden. Die Fotos sind so genau, dass auf ihnen selbst der Pathfinder mit seinem kleinen Roboter zu erkennen sein wird, der seit Anfang Juli die Marsoberfläche erkundet und sensationelle Fotos zur Erde zurückfunkte. Die ersten Menschen werden nicht vor dem Jahre 2010 auf dem roten Planeten landen. Aber NASA-Missionschef Cunningham verkündete heute schon: Hallo Mars, da sind wir und wir werden lange bleiben.
Hello Mars, we're here to stay and we're here to stay for a long, long time.
Im All. Eine neue Raumsonde liefert Bilder vom Mars. Hier sind die...
Der Mars hat in der vergangenen Nacht erneut Besuch von der Erde bekommen. Einen Satelliten namens Global Surveyor. In den nächsten 2 Jahren soll er den Mars umkreisen und eine detaillierte Karte von der Oberfläche erstellen. Vielleicht werden wir dann doch noch mal erfahren, ob es einmal Leben gegeben hat auf dem Planeten. Jens-Uwe Meyer.
Es waren bange Minuten im Kontrollzentrum. Für kurze Zeit war Global Surveyor hinter dem Mars verschwunden. Die Computerbildschirme signalisierten keinen Kontakt. Dann Erleichterung. Die Sonde war wie geplant in der Mars-Umlaufbahn. In den nächsten Monaten soll der Global Surveyor sich nach und nach immer weiter der Oberfläche annähern, wobei er seine Sonnenkollektoren wie eine Art Segel benutzt. Mit Laserstrahlen soll der Mars danach genauestens abgetastet werden. Wir wissen bis heute nicht, wie die Oberfläche des Planeten genau beschaffen ist, welche Mineralien wo vorkommen. Der Global Surveyor soll uns eine Datenbank erstellen, die dann die Grundlage für zukünftige Missionen ist. Der Global Surveyor ist Teil 2 der Mars-Expedition, die bis ins nächste Jahrtausend andauern soll. Im Abstand von 26 Monaten will die NASA weitere Sonden schicken. Am 4. Juli war der Pathfinder auf dem Mars gelandet. Das kleine Auto sollte eigentlich für nur eine Woche Bilder liefern, doch es fährt immer noch.
München, Kalifornien, Mars. Die Reisestrecke zwischen den beiden ersten Orten und dem dritten beträgt so etwa 700 Millionen Kilometer. Kann manchmal auch etwas weniger sein. Nichtsdestotrotz, auch wenn der Mensch seine Probleme hier unten auf der Erde noch längst nicht in den Griff bekommen hat, es drängt uns zu neuen Ufern in neue steinige Wüsten. Da ist jetzt schon wieder ein Gefährt von der Erde in die Nähe des Mars gekommen. Und in München tagten heute allerlei Experten, die die Expedition mit großer Verzückung verfolgten. Hildegard Werth schaute ihnen zu.
Nein, es ist nicht das Mars-Auto Sojourner, das sich hier an einem Felsbrocken abrackert. Es ist bereits ein Nachfolgemodell, made in Germany. Um das Jahr 2000 herum könnte es den roten Planeten beschnüffeln. Kleiner, leichter und noch leistungsfähiger als sein Vorgänger. Noch ist es nur ein Sandkastenspiel. Doch seit heute Nacht ist auch die Reise von Menschen zum Mars ein Stückchen näher gerückt. 10 Monate nach dem Start ist die neue Mars-Sonde Global Surveyor in die Umlaufbahn eingeschwenkt, nach einem Bremsmanöver von 22 Minuten. Jubel in Pasadena, dass es geklappt hat. In dieser kritischen Phase war erst vor 4 Jahren der milliardenteure Mars Observer auf Nimmerwiedersehen verschwunden. Am Ziel ist Global Surveyor damit aber noch lange nicht. 4 Monate lang muss er in seine endgültige Position manövriert werden. Dabei wird ein neues Bremsverfahren ausprobiert, das sogenannte Aerobraking.
Ob er wirklich in den oberen Schichten der Atmosphäre diese Bremsmanöver, die noch nie durchgeführt worden sind, wirklich so durchführt, wie wir uns das denken. Das ist natürlich die große Frage hier. Wir wollen bis zu 400 Mal in die Atmosphäre eintauchen. Und bei jedem Eintauchen wird durch den Luftwiderstand etwas gebremst.
Danach wird Global Surveyor den Mars alle 2 Stunden von Pol zu Pol umrunden. Aus 378 Kilometer Höhe schickt er Fotos, die zu einer sehr genauen Marskarte zusammengesetzt werden. Vorbereitung für eine spätere Landung von Astronauten. Seit der erfolgreichen Pathfinder Sojourner-Mission scheinen die vielen teuren Fehlschläge der Marsforschung vergessen. Visionen sind angesagt. NASA-Mann von Puttkammer ist auf Promotion-Tour in Deutschland, um raumfahrtverdrossenen Politikern neue Begeisterung einzuhauchen. Warum es das Schicksal der Menschheit sei, zum Mars zu fliegen, hat er in seinem neuen Buch erläutert. Und er wiederholt es gern und mit Nachdruck.
Das Schicksal deswegen, weil ich überzeugt bin, dass wir vorprogrammiert sind. So genauso wie das Leben einst aus dem Wasser ans Land gekrochen ist und vom Land in die Luft gegangen ist und hat Flugzeuge gebaut. Und heute fliegt es vom Luftraum in den Weltraum mit Raumschiffen. Das ist ein Fortschritt, wenn man mal so über die Milliarden Jahre zurückschaut, der irgendwie zwangsmäßig erfolgt, Schritt für Schritt. Da können wir noch so viel dagegen sein, noch so viel argumentieren, es wird gemacht.
Inzwischen können sich die Amerikaner sogar einen international bemannten Marsflug vorstellen. Frühester Termin weit im nächsten Jahrtausend. Der 20. Juli 2019 wäre ein passendes Datum, der 50. Jahrestag der Mondlandung. Die Kids, die hier so begeistert üben, wären dann genau im richtigen Alter, um mitzufliegen. Zumindest haben sie eine gute Chance, es im Fernsehen, falls es das dann noch gibt, live mitzuerleben.
Naja, so ganz habe ich natürlich immer noch nicht verstanden, warum uns Menschen ausgerechnet der Mars so anzieht. Doch geben wir nicht auf. Nach der Sendung Aspekte um 22:45 Uhr in Willemsens Woche. Jetzt wieder freitags im ZDF. Da taucht der Mann von der NASA mit seinem Buch wieder auf und Willemsen auf seine sensible Art wird ihm die wahren und die tieferen Motive dann schon entlocken. Danach 11:45 heute Nacht. Von uns hier auf Wiedersehen. Bis morgen.
Und Herren, seit Wochen schon gucken wir gebannt auf den Mars und auf alle Bilder, die uns farbig retuschiert, denn im Grunde genommen sind die erst schwarz-weiß von dort erreichen. Wir haben eingeladen zu diesem Thema, nachdem gestern die Mars-Sonde in die Mars-Atmosphäre eingetaucht ist und wir nun ganz neue Bilder erwarten können. Wir haben eingeladen den Chefplaner bei der NASA für das ganze Unternehmen, nämlich Professor Jesko von Puttkammer. Oh, jetzt muss ich erst sagen, hier spricht wirklich ein Kenner, Till. Er hat sofort gesagt, fly me to the moon. Und hat erkannt, dass das das Motiv war. Respekt, Respekt.
Das haben sie in den 60er Jahren immer gespielt, wenn Werner von Braun, mein früherer Chef, auftrat.
Ja, der Sie auch zur NASA geholt hat,
Jawohl.
muss man sagen, als
Ja,
junger
genau.
Mann.
Ja, ja.
Herr Professor Puttkammer, gestern ist die Mars-Sonde in die Mars-Atmosphäre eingetreten. Wir erwarten eigentlich neue Bilder, wir erwarten eine kartografische Vermessung
Jawohl.
des Mars. Was haben wir sonst zu erwarten, was werden wir genau sehen können?
Naja, es dauert noch ein Weilchen. Sie ist nicht in die Atmosphäre eingetreten, sie ist in einen Orbit um den Mars herum eingeschossen, der sehr elliptisch ist und sich nun über die nächsten Wochen und Monate hinweg Schritt für Schritt verengen wird und zu einer Kreisbahn verändern wir dadurch, dass sie bis zu 400 Mal in die Atmosphäre eintaucht und die Atmosphäre als Bremsmittel benutzt. Dadurch sparen wir uns den Treibstoff für einen Raketenschub und können dadurch eine billigere und leichtere Sonde bauen. Aber ob dieses Aero-Bremsmanöver wirklich funktioniert, wird sich erst zeigen. Das ist das erste Mal, dass wir das machen.
Also das Wort Aero-Bremsmanöver ist in dieser Sendung noch nie gefallen.
Ja.
Das soll nicht darüber hinwegtäuschen.
Ist auch noch nie gemacht worden.
Soll nicht darüber hinwegtäuschen, dass Sie im Grunde ein Visionär sind, unabhängig von diesen sehr praktischen Dingen. Das heißt, Sie denken eigentlich bereits in Schritten bis zur möglichen Besiedlung des Mars. Und das wollen wir auch nachher noch kurz unter die Lupe nehmen.
Ja.
Nur zunächst mal könnte man vielleicht fragen, 26 Kilometer hohe Vulkane, sehr tiefe Bodentemperaturen, ich glaube unter 60 Grad oder um die 60
Zur
Grad
Nacht,
ungefähr.
ja. Zur Nachtzeiten.
Wie wollen Sie den Leuten sagen, verlasst Wandsbek Ost, geht auf den Mars?
Ja, Leute, wir sprechen ja nicht zu euch heute, wir sprechen zu euch 30, 40, 50 Jahre von heute. Und dann wird sicherlich mancher in Wandsbek ganz gerne zum Mars fliegen wollen.
Weil es dort Biotope gibt?
Nein, es wird natürlich zunächst einmal der Forschungstrieb in uns, viele Jugendliche, dazu treiben, als Erste den Schritt auf den Mars zu setzen. Der Mars hat Rohstoffe, der Mars hat eine Atmosphäre, er ist ein Bruder der Erde an sich und wir können ihn über die Jahrzehnte und Jahrhunderte hinweg zu einem neuen Ableger der menschlichen Gesellschaft, der menschlichen Zivilisation entwickeln. Nämlich? Aber das ist nicht der erste Grund, warum wir dort landen, denn die wissenschaftliche Forschung geht vor. Wir wollen den Mars benutzen als Vergleichsmodell zur Erde. Das, was wir auf dem Mars entdecken, gibt uns neues Wissen, um unsere eigene Erde besser zu verstehen, unsere eigene Umwelt, unsere Klimaveränderungen, unsere Vergangenheit, Geschichte und Zukunft. Zweitens suchen wir auf dem Mars nach Leben. Und zum Dritten untersuchen wir den Mars im Hinblick auf eine mögliche Besiedlung eines fernen Tages.
Sie sagen, Sie suchen Leben. Bakterien, glaube ich, wurden gefunden. Die zählen nicht unter Leben.
Es ist umstritten, ob es sich wirklich um Bakterien vom Mars handelt. Das steht noch aus. Aber es hat auf jeden Fall die Neugierde der Mikrobiologen und der Archäobiologen wachgekitzelt. Sie bekommen mehr Finanzen jetzt. Und die Forschung auf dem Gebiet ist dadurch angekurbelt worden.
Bezeichnenderweise ist in Ihren Ausführungen bisher der Mond noch nicht vorgekommen. Man könnte ja sagen, warum das alles nicht mit dem Mond? Nun werden Sie sagen, die klimatischen Bedingungen stimmen nicht und das wird nicht gehen. Nur, war die Mondmission eigentlich völlig vergeblich, außer wenn man sich vorstellt, wir sind vielleicht imstande, den Mond zu nutzen als eine Art Zwischenlager, bis man zum Mars kommt oder etwas Verwandtes?
Nein,
oder für die AKWs, die dürfen dann steuern.
Ja, ich gehörte ja selber auch zu dem Team, das die Mondlandung damals ermöglicht hat unter Werner von Braun, und wir sind 6-mal auf dem Mond gelandet. Für uns in Amerika gilt einfach, wir waren schon mal dort, ja, we've been there, we've done it.
We've taken photographs.
Ja, jetzt wollen wir was Neues haben. Und wir haben natürlich, ich spreche jetzt mal von der Öffentlichkeit an sich, wie die das sieht. Wir haben auf dem Mond natürlich viel Wertvolles für die Wissenschaft entdeckt. Wir haben aber auch entdeckt, dass der Mond wirklich tot ist und dass er für die Zukunft der Menschheit an sich wenig Chancen bietet. Natürlich wird es auf dem Mond eines Tages einen Außenposten geben für wissenschaftliche Zwecke. Auch auf der Rückseite des Mondes kann man Radioantennen aufbauen, um dort in der Stille, in der absoluten Funkstille, den Kosmos zu untersuchen. Aber wenn ich nun an Menschen, an Kolonien denke, an Basiscamps, dann kommt nur der Mars mit seinen Lebensmöglichkeiten in Frage.
Dann wollen wir ganz kurz diese Vision weiterdenken. Das würde heißen, Populationen unter, ich sage es vereinfacht, Plexiglaskuppeln, die atmosphärisch aufgeladen würden, in denen sowas wie Biotope entstehen könnten. Ernährt durch, sagen wir mal, Sauerstoff, der von der Erde herantransportiert wird.
Nein, der auf dem Mars gewonnen wird. Der Mars hat Sauerstoff, der Mars hat viele Rohstoffe. Die Atmosphäre besteht aus Kohlendioxid, CO2, daraus kann ich natürlich O2, nämlich Sauerstoff, gewinnen. Und im Boden sind auch wertvolle Mineralien enthalten, die ich eines Tages gewinnen kann. Man würde zunächst natürlich seine eigenen Habitate mitbringen und in einer Art U-Boot-Atmosphäre zunächst leben. Man würde ins Freie gehen in Raumanzügen oder sich auch unter der Erde Habitate schaffen und dann Zug um Zug seinen Luxus, seine Lebenszustände dort ausdehnen und verbessern, evolutiv über die Jahrzehnte hinweg, bis eines Tages zum Beispiel Plastikkuppeln einem die Möglichkeit geben, unter freiem Himmel, ohne Raumanzug, unter den Sternen Lust zu wandeln und die Erde dort oben zu sehen.
Was wahrscheinlich zu den rührendsten Bildern überhaupt gehört.
Ich bin überzeugt davon, wenn den Einfluss, den der Anblick der Erde vom Mond aus schon auf uns gehabt hat, der hat nämlich die ganze Umweltbewegung angeheizt. Was für einen Einfluss muss erst der Anblick der Erde als kleiner Stern unter Millionen anderen Sternen auf uns haben?
Kann denn dieses Individuum, das da den Mars besiedeln könnte, im idealen Falle sollte man mit der bemannten Raumfahrt zum Mars, glaube ich, beginnen zum 50. Jahrestag der Mondlandung, so ist es geplant, kann dieses Individuum dort überleben, wenn es nicht vorher gentechnisch manipuliert oder, sagen wir mal, sich assimiliert hat?
Nein, wir würden unsere Lebensumstände mitnehmen und die auch künstlich dort erzeugen zunächst einmal, bis man vielleicht eines Tages, wenn dafür die Umstände richtig sind, wenn man zum Beispiel entdeckt hat, dass es auf dem Mars kein eigenes Leben gibt, das wissen wir ja noch nicht. Wenn man ganz sicher ist, dass es auf dem Mars kein eigenes Leben gibt, könnte man sogar den Mars durch Ökosynthese umwandeln, sodass er zu einer zweiten Erde wird. Zum Beispiel der Treibhauseffekt auf der Erde, der uns ja hier stört und schadet, beweist ja, dass wir auf unsere eigenen Klimata Einfluss nehmen können. Das können wir auch auf dem Mars, nur gezielt. Wir können dort den Mars erwärmen.
Also es würde auf dem Mars dauernd Haarspray
zum
in die Luft
Beispiel
geführt werden und irgendwann haben wir dann da eine Ozonschicht.
Man müsste mengenweise Haarspray auf den Mars bringen. Aber das würde man erst dann machen dürfen, wenn man ganz sicher ist, dass kein eigenes Leben auf dem Mars existiert, das durch solche Terraforming, wie man das in Science Fiction genannt hat, also durch Ökosynthese, in Mitleidenschaft gezogen würde oder sogar ein Genozid, ein totalen globalen Mord erleben würde. Das sind neue ethische Überlegungen.
Es kann doch heißen, dass Leben, so wie es jetzt auf dem Mars entstehen könnte, nicht überleben kann, wenn der Mensch seine Form des Lebens dorthin bringt, richtig?
Das ist eine Möglichkeit. Bewiesen ist es natürlich nicht. Es ist natürlich auch möglich, dass, wenn wir Leben auf dem Mars finden, wenn es wirklich noch Mikroben gibt, die dort leben können, in ganz bestimmten Nischen, die noch warm genug sind, dass das Wasser flüssig sein kann, dann besteht natürlich die Möglichkeit, dass wir das, wenn wir unsere eigene Umwelt dorthin bringen, dieses Leben auslöschen. Es besteht auch die Möglichkeit, dass dieses Leben sich umändern kann, adaptieren kann. Leben ist sehr zäh. Und wenn dieses Leben all diese Millionen Jahre auf dem Mars überlebt hat unter diesen widrigen Umständen, dann ist das so flexibel, dass es sicherlich auch die Landung des Menschen überleben kann.
Ich stelle mir gerade vor, wie Sie zu Hause sitzen und Ihre Frau sagt, komm zum Essen und Sie sagen, ich bin gerade dabei, das Leben neu zu designen. Also das sind, die Perspektiven sind enorm dabei. Jetzt stelle ich mir vor, dass eine solche Unternehmung nur ginge als internationale Anstrengung. Jetzt sagen wir mal, Deutschland ist erstmal aus der bemannten Raumfahrt ausgestiegen. Da kann nichts darüber hinwegtäuschen, dass man immer hier sagt, der Sojourner sei eigentlich ein deutsches Instrument und das sei schon das 17. Bundesland der Mars. Aber eigentlich ist es nur eine Zulieferung gewesen und ist eine eher marginale Form. Gut. Ja. Jetzt stelle ich mir vor, es sind die Inder zum Beispiel darin. Und die Inder sind ein sehr friedfertiges Volk und die werden sagen, erstens darf doch kein Leben zerstört werden und zweitens darf man auch keine Tiere und sowas benutzen für bemannte Raumflüge. Was sagt Professor Puttkammer?
Ja, das ist ein ethischer Aspekt, der durchaus auch von unserem wachsenden Bewusstsein für neue Ethik beachtet werden müsste. Auch Ethik hat sich evolutiv verändert. Wenn wir ins Altertum schauen, ins Mittelalter, wo die Leute mit großem Vergnügen zu Hinrichtungen gegangen sind und haben Folterszenen sich angeschaut auf dem Marktplatz. Das haben die nicht aus Sadomasochismus gemacht, sondern weil sie einfach das Gefühl dafür nicht hatten, dass sowas nicht gemacht wird. Erst das Christentum hat Konzepte wie Gnade und Erbarmen und Mitleid eigentlich eingeführt. Vorher hatte der Mensch überhaupt nicht den Sinn dafür gehabt. Und so hat sich die Ethik immer weiter verändert. Heute ist man umweltbewusst geworden dadurch. Und eines Tages, wenn wir auf dem Mars landen oder die Reife bekommen haben, um auch zu den Sternen fliegen zu können, müssen wir auch eine neue Ethik mitnehmen. Sonst sind wir da einfach dafür noch nicht die richtigen Menschen.
Also es werden nicht nur die Inder sein, die unter Umständen den Finger heben, es könnten auch die Frauen den Finger heben und sagen, der Mars ist immer ein männlicher Himmelskörper gewesen, wird mit dem Kriegsgott identifiziert.
Ja, das war sehr chauvinistisch von den Männern, aber auf der anderen Seite haben die Frauen sich die Venus gekidnappt. Und,
da fährt auch keiner hin.
Da wollen die Männer natürlich wieder nichts mit zu tun haben. Also man muss natürlich,
die
wie
Männer
gesagt, was sie meinen, ist, dass der Mars immer das männliche Symbol war, weil er ja rot war, Feuer und Krieg. Und Gewalt und Macht war ja absolut männlich, denn die Männer sind ja so zerstörerisch, während die schöne silbrige Venus das weibliche Prinzip verkörperte und mit einer Göttin, nämlich der Venus, ja personifiziert wurde. Und die hat ja auch den Mars geheiratet. Das heißt also doch zusammengekommen.
Also was wir jetzt nicht berücksichtigt haben, sind zum Beispiel religiöse Schlussfolgerungen aus dem, was Sie sagen. Zum Beispiel könnte man sich fragen, sind Erde und Mars eigentlich gleichzeitig entstanden oder sind sie durch Meteoritenpost von irgendwo kommen und über das All verteilt worden?
Nein, so viel wir heute wissen, sind Erde und Mars und auch die anderen Planeten alle ungefähr zur gleichen Zeit entstanden. Das heißt, Mars und Erde sind wirklich aus dem gleichen Mutterschoß entsprungen. Das sind also Brüder. Und haben sich aber total unterschiedlich entwickelt. Obwohl Mars ist viel kleiner als die Erde und ist einen ganz anderen Weg gegangen. Und die Frage, warum hat sich Mars so völlig anders entwickelt als die Erde, ist eine der größten und unbekanntesten Fragen, die wir noch beantworten müssen. Denn aus der Beantwortung solcher Fragen lernen wir mehr über unsere eigene Erde wissen. Wir gehen also zum Mars, um unser Wissen zu bereichern, um klüger zu werden. Das ist der allererste Grund. Der zweite Grund ist, um nach anderem Leben zu suchen. Und da kommen die Religionen mit dazu. Und die meisten Religionen, die sich dazu geäußert haben, als diese Mars-Meteoriten untersucht wurden, waren an sich durchaus adaptabel. Die haben gesagt, ja, damit können wir leben. Und die dritte große Frage, warum wir zum Mars wollen, ist, können wir eines Tages selber darauf Fuß fassen? Und das wird kommen. Da können wir heute noch so sehr das in Frage stellen, 1997, der Mensch wird dorthin gehen.
Gut, jetzt muss ich eine allerletzte Frage stellen, die ich mir auch deshalb erlaube, weil Sie Mitberater, wissenschaftlicher Berater bei der ersten Star Trek-Folge gewesen sind.
Ach, das wissen Sie auch?
Und das weiß ich auch.
Das habe ich Ihnen aber
und
nicht
es
gesagt.
Gibt ja, nein, aber das war wohl so.
Ja, das war
also es
wohl
gibt
so.
Kritiker der Mars-Mission, die sagen, nicht nur ist es so, dass die Menschen vielleicht da Leben finden, sondern die machen mögliche Aliens erst auf uns aufmerksam durch ihr Treiben da oben.
Ja.
Jetzt weiß ich, dass es bei der NASA nicht ihr direkt untergeordnet, aber beigeordnet ein Komitee gibt, das sich darauf vorbereitet, die Aliens oder was immer freundlich zu begrüßen. Und ich weiß, dass Sie auch schon mal freundlicherweise daran teilgenommen haben. Sie gehören nicht zu dem Komitee, aber haben teilgenommen. Denkt man da an Hymnen, an Flaggen hochziehen, Grit Breuer nochmal laufen lassen oder einen Felmi-Film zeigen oder an was ist gedacht?
Ja, zunächst mal muss er natürlich auf die Willemsens Wochenschau kommen, der Alien. Ja, das ist mal ganz klar, weil er dort ganz nett behandelt wird. Nein, aber wie gesagt, es gab diese Versuche, dieses Komitee besteht also aus Leuten außerhalb der NASA. Da ist ein Poet dabei gewesen, ein Pfarrer und so weiter, ein Philosoph. Und man ist an sich zu keiner richtigen Lösung gekommen. Man hat an sich festgestellt, wir sind eigentlich heute als Menschen noch gar nicht reif, einen Alien wirklich empfangen zu können, solange wir noch Angst vor ihm haben oder umgekehrt vielleicht zu viele von uns gleich öffnen, zu freundlich sind, bevor wir ihn kennen, dass wir an sich selber heute gar nicht die Möglichkeit haben, sagen wir, als Botschafter einer anderen Zivilisation so aufzutreten, wie man das gerne in Science Fiction hätte. Also wie gesagt, dieses Komitee ist nicht eine formelle Sache. Ja, das ist also nicht etwas, was die NASA macht.
Das hätte sich sonst auch bestimmt der eine oder andere beworben. Ich kann jedenfalls sagen, dass Sie bestimmt Lust bekommen haben auf die zahlreichen Perspektiven, die dieses Thema hat. Und wenn Sie sich damit mehr beschäftigen müssen, dann empfehlen wir natürlich Jesko von Puttkamers Jahrtausendprojekt Mars, Chance und Schicksal der Menschheit. Ich stelle mir vor, dass das im Jahre 2400 auf dem Mars als alte antiquarische Schwarte gelesen wird, die wir wie Jules Verne zur Kenntnis nehmen und sagen, was hat der Mann sich ausgedacht. Es war großartig, Sie hier zu haben. Haben Sie vielen Dank, Herr Professor Puttkammer. Wiedersehen.
Da hat sich nach 2 Wochen wieder auf der Erde gemeldet. Aber weder die Sonde noch das Roboterfahrzeug Sojourner haben genug Energie, um neue Bilder zur Erde zu übermitteln. Dennoch soll Sojourner kleine Sanddünen auf dem Mars entdeckt haben. Wie auf diesen Fotos sind die Sandhügel nur wenige Zentimeter hoch. NASA-Wissenschaftler glauben, die Dünen sind ein Hinweis unter anderem dafür, dass es früher einmal Wasser auf dem Mars gegeben hat.
Although the initial excitement over the stunning first pictures has faded a little, the science is starting to pour in, and right now the focus is on Mars rocks.
The latest data from NASA's Mars Pathfinder mission provide new hints that Mars once had a climate that could have supported life. That's the conclusion some scientists are drawing from a careful study of rocks on the Martian surface. They think the rocks are a type called conglomerates, made of water-worn pebbles that get stuck together.
It requires long eras of liquid water rolling past those rocks to round them. And until we saw this rock up close, I would say that there's been quite a bit of argument in the science community as to whether Mars had a warmer and wetter past. Perhaps early Mars was, in fact, much more like the Earth. That then goes to that fundamental $24,000 question of, are we alone in the universe? If liquid water was stable at that time on Mars, did life develop? If it did, what happened to it? And if it didn't, why not?
Among other new findings, Mars is not just a ball of rock, but has an outer crust and a core like Earth. And for the first time, scientists think they found sand as well as dust in Martian dunes. Pathfinder is communicating with Earth again after a gap of 9 days. Scientists are happy to reestablish contact, but working to figure out what went wrong.
It may be slow getting back, maybe a week to this operational during the day, getting the science data we were taking before, but we have no reason to believe that's not going to happen.
When Pathfinder landed on Mars on July 4th, it was officially scheduled to keep going for a month. So it's already far outlived expectations. And some members of the team hope it will just keep going.
As I've been telling everyone, I hope to have this job for a year.
NASA says the Mars Pathfinder mission has entered its twilight phase. Over the past month, communication with the Pathfinder lander has dwindled to virtually nothing. Pathfinder wowed both scientists and the public when it landed on Mars last July 4th and deployed its little rover Sojourner. In addition to sending back stunning pictures of the Martian landscape, Pathfinder has also been a scientific success. Among the most important findings, Mars has a metal core, which could only have been formed in the presence of heat. And that means conditions on the planet may once have been right to support life.
The tiny craft that dazzled the world with pictures of the red planet has been silent for about a month now. However, as CNN's Greg Lamont reports, scientists are not giving up hope just yet.
Just months ago, scientists at the Jet Propulsion Laboratory in Pasadena, California, were on an emotional high they could barely describe. It was July 4th. The 5-year project known as Pathfinder had landed on Mars. Data and photographs of the red planet soon followed. It was described as the most successful interplanetary project ever. But today, Pathfinder appears to be lost. Communications with the Pathfinder lander and Mars rover ceased September 27th. It's believed severe cold rendered the craft inoperable.
What we've been doing in the meantime is trying to send commands and trying to recover the spacecraft so we can continue operations, but at this point we haven't heard anything.
No one associated with the mission wanted it to end this way. But before you start feeling badly about it, keep in mind the mission lasted almost 3 times longer than scientists had anticipated. And while the hardware may be lost, scientists have just begun to analyze the 2.6 billion bits of information sent back to Earth, as well as 16,000 images and 15 chemical analysis of rocks and soil.
Pathfinder will be judged in the future by how well its data is used. So, I mean, for example, 21 years later, we're still using Viking data. So that shows you, how good the Viking mission was. So I think the future generations will decide how well Pathfinder is.
In addition, scientists are already gearing up for 2 more missions to Mars, set to begin late next year.
One's going to land at the South Pole, dig up some dirt and measure the water content of the dirt. And then we're already starting to design the 2001 missions, which will be a lander, an orbiter, and a rover.
In the meantime, by Tuesday evening, all efforts to make contact with Pathfinder will have been fully exhausted. Even so, commands will be sent to the spacecraft about once a month for the next year in hopes of regaining control. Greg Lamont, CNN, the Jet Propulsion Laboratory, Pasadena, California.
Another space story that mesmerized the world has apparently come to an end. Now it's time to say farewell to that fearless explorer, the Pathfinder. The mission, starring Sojourner, the little rover that could, is out of commission on Mars. Other than a couple of beeps, NASA hasn't had any real communication with the spacecraft since September 27th. Cold temperatures and battery failure apparently led to the shutdown.